Hello. Okay, we've got our plan. We've got our plan for today. We've currently got our click tracking AI, and you can see here that it sort of averages out in the middle where all the clicks have happened. Just kind of, well, eventually it gets there. You can see it trying to learn right now. See, it'll get there. It gets there. Hey, how's it going, SAQ 3000? Neva, good. Are we doing the thing now? We are doing the thing now. You've been summoned. Hey, SAQ 3000, good to see you. Good to see you, Neva. We're going to be updating our... Hey, Neva, we're taking your idea. So remember on last week, on Friday, where we had the click tracker, we're going to implement the CNN, the Convolutional Neural Network. We're going to see if that does the trick. I think it will. And so that's the plan for today. We're going to be taking our click tracker. That's going to see if we can figure it out. I think it can. Just a random, oh, hey, how's it going? Just a random limmer. Hi, you're there first. Good to see you. Welcome on in. Yep, so we've got our click tracker, which is an AI that learns to predict where the user's next click is going to be. We want to make it better. That's what we want to do. We want to make it better. And I think we can do it. That's the plan. Oh, so third right and 3D and 2D canvas time plus time. Neva, we'll do the best. You help us as we proceed forward. Let me know how we can make it better. I've only ever dabbled in CNNs many years ago, and I think it's going to make it a lot better. Also, one second, we can also do some other things. So right now, as you can tell, the click, there's no randomization in the training epoch. There's only one training epoch. Just one training epoch. So let me update this. So we need to add some more to-do items here. Okay, let's see if we can do this. To-do items. All right, so more than one, put the spaces in the right spot. More than one training epoch. Okay. And then we need to, Stephen, please check out HRM 270 million beating latest chat GPT. That's 30 trillion parameters. Are you serious? Really? Maybe start drawing software, just sketching the architecture so we know what we're building. I think we should be able to see it all on the screen. So actually, that's a good idea. Because we need to define how many filters there are. I understand the filters. I understand the filters that are capturing the data in the window. Now, we don't have a lot of input data. So that's one of the challenges, right? We don't have a ton of input data. So I'm interested in making sure that we can capture as much meaning and intent within it, or if we need to collect a lot more clicks, right, as the input window, which might be something that we need to do. Beating on a specific task. Oh, got it. Okay. I'm actually, let's check SAQ 3000. We'll check it out. Can you please remind me what we're doing? I am curiously weighted. Okay. Just a random learner. So we've got here, let's just double check. Let's go back over here. So check this out. So we've got this, these are all the green dots on the screen are me clicking on with my mouse. So me clicking with the mouse. And I've recorded all those. And that is the input data for an AI model that we created previous streams. And the yellow dot is the output where it's trying to predict where the user is going to click next. As you can see, the yellow dot doesn't totally do a perfect job. It's not fully doing a great job. So we need to modify the model to make it good. We want to make it good. We'll Googling it because I'm not on Discord. All right, we'll Google it here in a second. We'll definitely Google it. So I was just describing to just a random learner what we're doing. And so now we want to get this yellow dot, which is being weird right now. And we want it to do the best it possibly can at predicting where the user is going to click next. That's the idea. So, okay, got it. Thanks. All right, great. So we have a few to-do items, and really quick, SAQ 2000 was, hey, why don't we check out this one thing really quick? So here's the CNN that I'm looking at really quick. So we'll do something simple and small and tiny. And so we'll be adding this. Actually, we'll probably creating a new model, and then using that as, because our current model looks like this. Let's see, model. Where is that at? Where is it? No, MOD. I know it's there. Here, right. So here's our current model. Basic, simple model. Neva, right here, said to use CNN. Maybe all LSTM as well for time series. We'll see how that works. So let's check this out. HRM27M. Okay, so HRM is a 27 million parameter model that beats ChatGPT, currently a 30 trillion parameter model in some certain cases. Let's see here. HRM refers to, HRM 27 million model benchmark. See if you can see that. Is there anything like this? Hierarchical reasoning model shows remarkable benchmark, especially on reasoning tasks like the ARC AGI challenge, outperforming much larger LLMs using a brain-inspired layer approach instead of a brute force scale, achieving 40% on ARC AGI. What do you know? SAQ 3000. That's really impressive, and it's only a much mini smaller. Like, this is a model size that you could run on your computer, no problem. You could do that really easily. I think you can train it yourself. Do it. That would be neat. That would be really neat, right? Yeah, they started doing that kind of splitting thing. Really? Really? All right. The more we know. The more we know. Luna the Snake. Can I be a mod? Sure. Okay. I'll click you the button. Luna the Snake. All right, let me see here. Put user as mod. All right, standard. There you go. Did it work? Let me know if it worked. Let me know if it worked there. Let's see here. Let's see what we could do about this. I think we need to pull that here, maybe. One moment here. Okay. Cool. Excellent. Okay. Nice. All right. Brain-inspired mimics human cognition with 2 recurrent modules. All right. Slow planning, fast reactive for iterative reasoning. Neat. And 1 pass. All right. Bigger is better. Challenge is the bigger is better trend showing smarter compact designs can excel. So my question is, can we make this really small 27 million parameter model bigger to make it scale more? Can we do that too? Yep, it worked. Nice. You remember from ChatGPT, you saw they did the mixture of experts. Oh, right, the MOE. And that seemed really cool. That was really neat, right? The mixture of experts idea. I thought that was a neat innovation. So not all the parameters are activated during inference. And obviously during the training process. That is pretty neat. So only 1 or 2 of the experts are active at once. Yeah. Let's see. Is that available on Olama? Can we do that? Is that available here? Olama. Let's see. Let's go to models. Is there anything like, or is this here? HRM. Okay. So we probably have to go grab it from somewhere else. You haven't tried it yourself? You asked ChatGPT yeah. I know how to make mini rovers. Mini rovers? Really? What's a mini rover? What is a mini rover? I don't know if it's open source or not. Got it. Okay. So we'll have to wait. We'll have to wait. Okay, that sounds good. Sounds good to me. All right, let's see if we can get the CNN working. Let's see if we can get the CNN working here. I think we can. So we need, let's create a new one. Let's go over here to our code. All right, so we've got our, let's see. Oh, interesting. That is interesting. Okay. All right, so I think what we could do is we could just override this part right here, the model part, as a sequence. Well, can we do that? Yes, I think we can. We can put this into a sequence, and then that just replaces that model there. And then we should be able to easily, no problem, just replace this one bit here. I think that should be fine. Oh, weird. Seems like HRM runs a lot more compute for less params. See, that's what I was also wondering. You bring up a really good point, Never. I was wondering if for the number of parameters, sure, there are few parameters, does the algorithm, obviously, it's different than the standard one. How much different is it? Does it require a lot more compute? And yeah, it sounds like you're saying it does. And it's counter to conventional wisdom. All right. I mean, Stephen, use genetic algorithm to make this work. and learn basically anything. Yeah, well, I mean, right? We could. Is there one? What is the genetic algorithm? I'm actually kind of curious about that. What is the genetic algorithm when it comes to machine learning? I mean, I get the idea. You essentially have to create a whole bunch of models, have them train and learn over time, and then pick the winners. That would be the genetic algorithm, right? I think, pretty sure. So Luna, the random learner, just a random learner, or sorry, one second. Luna, all right. So basically the rover is like when you use a ton of screws and you have to like put it in with a little bit of plastic and metal. And then you put it on a motor, put in some wheels, and you're done. Oh, got it. Okay, got it. So it's like a very minimalistic car. Hey, the last attack, you're here. There are so many ready platforms for organizations, and implementation is easy. Do you think coding will vanish? I don't think so. I think coding is fine. I think we're good on coding. Hey, NVim Chad. Hey, how's it going? NeoVim Chad. Hey, Steven, how's it going? Yeah, sounds good, Luna. Yep. You've dotted the problem in a number of them somehow, and other jazz. Okay. AB Production, how's it going? What's up, Auntie? Good to see you. Happy Monday. Hope you had a good Christmas, everyone. Also, we're going to have a New Year's happening here pretty soon, aren't we? That's happening here pretty soon. So we're going to make a new model here, self.model. Also, I noticed that I don't have this here in predictor, self. I noticed that I didn't do that. Do I need to do this? Obviously, it worked just fine without it. Because I missed this part here, right? Let's actually check to see if that still works. Let's see if that still works. Yes, it still works, and nothing different. It doesn't matter. It doesn't seem to matter. I don't know why. There's no difference. Good morning and God bless. Hey, 313 Collector, good to see ya. Good morning. I had a good Christmas and forgot my present though. Oh no, you did. Go get it. Go get your present. NeoVim Chad, can you please make playlist course AI ML with Pytorch? That is a good idea. Let me write that down. OG Alex, man or woman, man. We are man here. Okay, let's close this really quick. Steven, why do magnets die after decades later? Are you talking about natural magnets or electromagnets? Electromagnets don't die, right? I think you're talking about natural magnets, right? And I assume something I don't know why. I actually don't know why. I'd have to look it up, and I would probably somewhat understand it. I don't know why, though. Happy New Year in advance, King Steven. 2026 will more successful for you. Thank you. Permanent magnets. Yes, okay, permanent magnets. Okay. Well, I don't know, although I assume obviously something runs out of energy. Or something's missing. I don't know exactly. I don't know. Let me write this down real quick. So, see, future stream idea 1 2 3 was a, what was it? Playlist course on AI/ML with Pytorch. So we've done a lot of videos with Pytorch. So what we could do is, actually, this is kind of like, so NeoVim Chad, you're essentially asking, why don't we put all of our Pytorch videos that we've made over time into a playlist? We can absolutely do that. I think it's a good idea. Let me just also write that down here. Okay. So I think we could do that. I think it's possible. Do you work at NASA, Luna? No, I work at my own company. I've got my own company here called PubNub. And I'm the CTO. We raised $134 million. We're on our Series E. We have over 1 billion connected devices and 68 patents that have been granted, or patent claims that have been granted to us. And I've been 25 years in tech. Let me edit that really quick. Let's see, basic info, 25 years in tech. There we go, save. So it's obvious what's going on when I say that. Okay, there we go. Wow, I know, isn't it neat? It's give me a job. Production. I'll let you know when we got more jobs. What's your age, bro? I'm just a little bit older than the Primogen. If you're familiar. And we've been both in Silicon Valley for many, many years, decades. Did lots of things, lots of different. We had been, doing all the things in technology. We did all the languages all throughout. When Node existed, when Git became a thing, when Git version control, SVM. There's so many things over there. You look so young, though. Thank you. Thank you for being inside and eating healthy. Is your code open source? Yes. So it is open source, 100% open source, except for PubNub. That code is proprietary and closed source. We do have patents, and you can see the patents. They are available here. The patents are publicly available, so you can see all the patents. Where are they at? Here you go. So you see all the patents here, various patents. Show all the patents. Yep, we got them. They're live. You can see them on Google Patent Search and everything. So, however, all the code that you see on stream, like this code here, is open source, and it's available on our Discord. It's available here on our Discord. So it's free forever, and I'll teach you everything. No charges. If you any questions, I'll be happy to tell you what worked for me over the years. I've had a lot of experience in tech, and we've scaled huge. We've got over 1 billion connected devices. So there's a lot that I could tell you about. I'm serious. I'll be your best employee. Thank you. Yeah, absolutely. AB production. We do have an open role. So here's the deal. We do have an open role. PubNub careers. Let's see here. PubNub careers. All right. Scroll down to here. We have an open role here, and it is in our Discord. So there you go. It's in our Discord. We are looking for a senior software engineer, and it's a remote position. Hey, Gemma. Hey, Gemma said hello. Hey, thank you. Welcome on in. Good to see you. Happy Monday. All right. So let's see if we can get our CNN going here. So we're going to do this. CNN equals. Well, actually, we're going to do the same thing here. CNN equals this. All right. So we're going to replace this. Okay. And we need to review. Thank you for the likes, you guys. Sifesh. I'm trying to say your name. Sifesh. Sifesi? I'm trying to. Hey, Lance, how's it going? Steven, we should really chat again. Lance, all right, sounds great. Lance, it sounds good. Send me a message, Lance, on our Discords, and we could, if you're here on our Discord, send me a direct message, and we can set up a meeting. And we can chat again, Lance. We could do it. We absolutely could do it. Sifes, Gemma, thank you for the smile. Steven, can you play Van She Kelsey, please? What is that? What is that? Take it down. You have your guy right here. I'm confident I can accommodate that role. I believe it. I believe it. So yeah, just shoot if you want. Yeah. So here, click the apply button, and then if you want, you could also forward me your resume on Discord, and I will send that to our hiring team. I'll send it to our hiring team. Banshee Kelsey, is that SAQ 3000? Is that music? Is that music that would be not Creative Commons? That has copyright? Is it SAQ 3000? Let me know. By the way, I am not a girl. My snake is. Look. Okay, you're a guy. All right. My snake is. I am a guy. All right. By the way, sounds good to me. Sounds good to me. Okay, so let's see if we can get back to this. I want to. All right, so we're going to be doing this. I'm not sure what I want our input to be. I suppose we could make it, because the pixel location is at a coordinate. It needs 2 positions, so I'm thinking like 1. Let's see if we can get this to work. So I'm gonna type this in. It's very nice music. Is it? But in terms of very nice music, is it free or is it right? That's my question. Is it Creative Commons? If it is, I will play it. Neovim Chad, bro, can you make a tutorial type of videos? Oh, that Pytorch and EOL course. Yes, gotcha. Like what you used to do for Rust videos. Yeah, that was a lot of fun, right? That was really neat. I will try to see. I've got it down here. Let's see here. So I've got it here. Wait, let me edit that really quick. That seems like it's incorrectly. So edit. Here we go. COURSE. There we go. With Pytorch. Pytorch. There we go. Save. Excellent. All right, we got it. Future ideas. We got them down. Okay, you can have it be a single highlighted pixel and the rest being 0. Oh, a 2D canvas. Okay. Yes, I understand. So Neva, you think that our input window we need to create during the encoding phase, or essentially as we're constructing the input for the convolutional neural network, we need to make essentially an image, a 2D image, which obviously gets flattened, but we'll have a 2D image that will have a bunch of zeros, but the beginning of the input image will be our input data. I think that's what you're saying. Here, no copyright for sure. I don't know about the SAQ2000. I don't know. We'll click the button. We'll click it here. All right. That seems pretty. Are you sure? I don't know. That seems copywritten. Do not own any rights on the music or song or lyrics. So it's not copyright. I don't want. It says fair use. Copyright disclaimer under section 107. Allowance is made for fair use. Hey, Stephen Art. Hey, how's it going, Savon? Good to see you. What did I miss? Hey, don't worry, you didn't miss anything. We're just going to be, the plan is we're just going to upgrade our AI model to use Neva's recommendation. We're using Neva's. Hey, sup, Stephen Isaac. Good to see you. Ever or plan on doing system architecture streaming? We could. Guidelines for production-ready architecture for medium to large-scale applications. Maybe how you handle data and security. Sure. Isaac, that sounds like a good one. You don't want to flatten it too early because the 2D structure is meaningful. Oh, okay. So does it need to be a two-dimensional array as opposed to a one-dimensional array? So if that's the case, we can make that happen. We can absolutely do that. We can do that. How do we do that? I need to think about, because we only have 6 input features, right? So 6 input features, that's not a lot. How do I check if it's got copyright or not? Well, I mean, it is Mr. Robot, right? So it says I do not own any rights on the song or lyrics. So it's not copyright intended or disclaimed. It looks like whoever posted it does not actually own the music, and that's what they're saying. They posted it, they don't own the music. However, the music probably is copywritten. So just in case, we'll hold back on it. I think 3D because we also have time. Oh, got it. Okay. Well, then we don't have a whole lot of data unless we want to sort of collect a whole bunch of data up front, right? So we need to collect a whole bunch of clicks, like mini clicks, like a lot of clicks. If we get enough clicks, then we'll have enough data. Let's at least get let's at least get this going here. So we're going to do sequential torch.nn .cnn. What was that? We're going to do this. Let's see. Oh, we'll just do this here. Okay. Torch nn conv2d. Okay. Did I do? I'm just checking to see here. Where's that at? Where's Torch at? Torch. Oh, it's right here. Oh, I already have nn opened. Okay, I already have nn available. Let me pull this up here at the top so I can get everything in the same spot. All right, excellent. You don't have a lot of weights in a CNN. It's just like 9 weights per layer. Is it really? That's not a lot. That's not a lot at all. Like you can keep it under 40 weights if you want and keep small data use. Excellent. Okay, that sounds good to me. That sounds good to me. Stephen, are you guys working on any kind of AI ML product at PubNub? Yes, we are. We are building built-in, for the most part, NLP, moderation, and automated development of applications that use our technology, embedding into our SDK. So we've got a lot of AI happening. A lot. Quite a bit. For 3D, it's 27. Just 27 parameters? That's amazing. Okay. We're going to try to get this to work. So, turns out we don't need this. Watch this right here. Okay, let's do this. We'll get rid of that because we don't need that. We'll just do nn. Well, let's use nn. nn.conv2d, right? 2d. And then our inputs, we'll kind of copy. I don't know what we actually need here. So there. Okay, sounds good to me. All right. And then we're going to have a max pool of 2x2. nn.max pool 2d. We'll start with 2D, and then we'll see if we can get up to 3D. 2. And then another conv. This time, though, it's bigger on the inputs. 6, because I don't know why yet. We'll figure it out. 16 and 5. Okay. Yeah, for having one channel, adding channels is giving you a multiplier for what the linear layer weights would be. So, oh, got it. So, I mean, because essentially each, this is saying how many RGB value, like is how many color channels there are, is my understanding, right? So if it's grayscale, it's going to be 1. If it's, red, green, blue, it'd be 3 as the input. And if it's red, green, blue, alpha, we'll have 4. And then if you have like, maybe, I don't know, radio frequency or it's gamma rays, right? You can put it up to 6. Like you could have a whole bunch of inputs. So I think just 1 for now. We'll just try 1. We'll see what happens. We'll see what happens with just 1. I think we'll find out. Okay. And then it wants, then we go into linear. Okay. So very simple up here at this, and then we'll go into linear. And what was the linear input? So why is it the input on the linear layer 16 by 4 by 4? See, this is what I'm not sure, but I suppose obviously it's based on the output from Conv 2D. 16 by 4 by 4 is interesting to me. Okay, so we're just gonna do this. Okay, and then 16 and 4. Obviously, this is going to make it see 32, 64, right? So this will be 64, and then 256. Does that make this 256 here? Did I math this out right? I'm gonna check really quick. Calculator. Simple math. All right, simple math. All right, 16 times 4 times 4. 256. I already know math. I know it's really simple, but all right. Yes. You got for 3D, you have 3 by 3 by 3 kernel, which is 27, adding a color, which would give you that 3x, which is 81. For the 3D, if we did 3D. Got it. Okay. Which would make sense. All right, so what is our okay. What else do we have here? Pool ReLU. Oh, I see what's going on. I see. All right, so the forward pass, it's I don't know if we can do, because I'm reading the forward pass here, the way how it works, I don't know if we can do a sequential. Although I suppose maybe apply first convolutional, which is conv 1. Where was the conv 1? Oh, we did a conv. Oh, got it. Okay. So these are just 2. Okay, so this is the first conv. Sounds good, X. And then it does ReLU, and then it does pool. Okay, so we need to do like this. Wait, let me read this. No, conv 1, ReLU needs to go here. Okay. And then pool on the outside. All right, so there we go. All right, so now we've done the sequence here. We got the sequence. And then what does the next look like here? So then it goes through the second and another ReLU and another pool. Okay. So we can do second ReLU and then pool again. What pool was it though? There's only one pool. Okay. So there we go. I think that's the same. I'm pretty sure that's the same. Let's double check it. Okay. Conv 1, yes. ReLU, yep. Max pool, yes. And then we do conv 2, yep. ReLU, and then pool. Okay, excellent. And then it looks like there is some sort of flatten here. Flatten all the dimensions except the batch. Okay, so this can we do a flatten here? I don't know if we can. Is it possible to do in.flat? Something like that. I don't know if we can. Does that work? Can we do that? Let's see. Python. Import Pytorch. Did I spell it right? Just torch. Okay. And then torch.nn.flatten. Yes, it is. Okay, great. Excellent. Okay. So I think we could do that. I'm pretty sure. We're going to find out. And then Oh, wait. So what is FC1? Oh, linear. Okay. So then we do a linear, linear, and linear with 2 ReLU activations. All right. So ReLU, another linear. But this linear needs to be different. That needs to be the same. So, wait, did it say 8? Oh, 120. Okay. I suppose we could put this up to 32 maybe. And we'll go over here and make this 32. And then it's saying, I don't know, we'll go, what is it? 8, 16. Let's try that. Another ReLU, and then an output, which will be our target out, which is basically this output here. There we go. There we go. Okay, 1 second here. Okay. What editor are you using? Samel, Xander. This is Vim. This is standard Vim. Standard Vim here. Let's see, W. So this is Vim version 91754. That's what we got right there. We got Vim. It's my favorite text editor. It makes me happy. It does all the things that we need it to do. Vim for the win. Yeah, you got it, Savan. Vim for the win. Okay. Talking to AI is like talking to a wall. Hey, yeah, sometimes it is. Yeah, yeah. Yeah. Bit it. Not even GVim. Yeah, it's regular Vim. We got standard Vim. Anti-gravity. Thoughts on anti-gravity? Is that a text editor? Oh, wait, that is a text editor, right? That's the new Google text editor where they acquired some text editor, VS Code fork, and that became the new, right? So so anti-gravity, what was anti-gravity originally? I forgot already. It goes, you used to use Emacs, really? Wow, Emacs with your Lisp, so much Lisp in there, right? In the past, but Vim is lighter on the key combos. Though I'm not an expert Vimmer. All right, nice. Google, yes. All right, nice, Google. AI Agentic ADE. There we go. That's the future. That is the future. Yep, that's anti-gravity. That is what anti-gravity is. YouTube algorithm thought I said something harmful. It didn't show my old text, bro. Yeah, it didn't. It didn't show up. Curse. Oh, was it? Wait, did you say they acquired Cursor? Did they? Wait, it was Cursor? Or was it like Windsurf or something? Who is it? Who acquired Cursor? All right. Let's see here. I'm reading through it really quick. The coding platform, blah, blah, blah. Cursor IDE. It says Cursor is still private and remains independent. It had to have been a different one. Windsurf. Got it. It was Windsurf. Ghost Wolf, thank you. Thank you. Thank you. Thank you. Hey, Quantify Quantum. Hey, welcome in. Good to see you. All right, you're here. Happy Monday. I think you're running this wrong, Steven. You need to run some feature engineering here. Like the input shape should be changed. Yes, you're 100% right. I got that. 100%. Neva, you're right. I know we have to do that. I'm very, very sure we have to do that. Because I need to change it so that way this is, I can get the right input shape for the first layer. Currently, it is only, it's a one-dimensional array with 6 input features. So we do need to change that. We do got to change that. You're totally right. You're absolutely right. We got to change that. We'll change it. To do, change input for CNN. All right, so we got to do that. We got to do that. All right, that's really good. The music flags people's videos to shut it down. Yeah, I know. SAQ 3000. Yeah. Windsurf. Yes, you're bad. No worries. It's all good. They got Windsurf. Yeah, they got Windsurf. Not entirely buying, but getting some of their staff. Ah, got it. Aquahire. I'm posting some async code on Discord. Can you do a quick review? Yeah, async code. I love async code. Hey, Dependabot, how's it going? Good morning. Welcome on in. Good to see you. Whoa. All right. I saw your code that you just posted. All right, let me pull it up here on stream here. Let me pull it up on stream. Oh, hey. All right, so we got some Python going on here. Let me copy this into a text editor. Async IO, nice. PB paste async.py via async. All right. Playwright. Oh, we got an agent. We're doing some agentic stuff here. Set wrap. Okay. All right. All right. Looks good. Semaphore. What are you doing over here with semaphores? Async the lock. Hold on. We've got some wait. No. Wait. There's immediately a weird problem here. We get some weirdness here. When you're dealing with async, you don't want to deal with semaphores or locks. What's going on? All right, you're mixing things in that you don't want to mix necessarily. You don't want to mix these things. With async IO, you want to be able to interact through message passing as much as possible to not block anything. So what you want to do is throw this into a thread and communicate through message passing. So that's the first thing that I see. It's weird. The first immediate thing. Quantum, here's your idea project. Use genetic algorithm to predict the future click event. Hey, Quantify Quantum, that's right. We're still working on your click prediction. We are converting it into CNN. You want to limit the resources for now? Got it. Okay, understood. Okay, so context, options, browser, semaphore acquire, lock, playwright for browser, right? For browser. Launch, headless, true. All right, sounds good to me. New context, JavaScript enabled. Base URL, self context. All right, so you put the URL. Activate active contexts. Okay, so you've incremented the contexts. Do we use this anywhere else? Decrement. Shut down if there's no active contexts. And 0. Otherwise, that's all it does. There's no... It just checks to see... Okay, so that's all that's used for. Okay. Either you do a multi-threaded code with semaphores and all the shebang, or use async. Right? I know, right? Savon, that seems like the right approach. Because if you're doing async, you don't need to use locks or semaphores. You could just track it using traditional tracking. Yep, basic code. All good. Explicit threads with standard thread scope. Like some explicit threads. See? That also works. Okay. Taking also here. Canceled error, which isn't really an error. It's just canceled. That's fine, though. That's how it is. Raise. So, okay. So you're having it bubble back up. Okay. Rollback partial state. If context is not none, close. All right. So just clean up. What is a exit? What is this? I've never seen this. What is a exit? I don't know what that is. I've never seen this before. Python a exit. Python. What is this? Is that a thing? Method is special asynchronous method that is part of the asynchronous context manager protocol. It's automatically called when exiting an async with block. Oh, that is neat. The more you know. Hey, we're learning new things today. And its primary purpose is to handle cleanup operations. Yep, there we go. All right, sounds good to me. I mean, okay, sounds good. Yeah, it's an exit hook. Nice. Very nice. Okay, so and the exit hook, context, await, active. Okay, if it's not none, then close, and then loop. Okay. Wait. Subtract 1. This seems like it's wrong. Does this seem wrong to me? This seems wrong, right? Because if there is a context, then it's just going to close and then it's going to close. So do we open up new context every time and that's incremented? Self.context. The primitive hook is actually across Python, not just in the async contexts. Got it. So is exit also a separate thing? You love Python too much? Nice, Savon, thank you. Thank you for helping us out. Thank you for loving Python too much. Okay. Semaphore release, finally. Okay, so that just goes through this. And then we've got a shutdown method. Active context, can't shut down. There's still open context. Does it? Okay, so if you attempt to shut down, it just won't, and it won't help you. It'll just stop. Await, close, await, stop. Done. Okay, clean up. So I don't know if you necessarily need to do these things here, because Python generally takes care of that for you. Hey, Gunhigh, it's good to see you. Pytorch again. Yep, I love AI content here, Steven. Let's go. Thank you. Yeah, me too. That's my favorite as well. That's also my favorite. So here's the great part. Quantify, if you're still here, taking a look at the code. It's very lightweight. It's clean. Only 68 lines of code. Very nice. I just think it's weird to be mixing in async code and things that you typically need to do locking for. With context lock, because I don't see any concurrency happening here as much. So it seems like it's just extra stuff without any purpose for it, as far as I can tell from what I'm reading. It seems like you could do away with a lot of these things. Like, why are we requiring a semaphore? Why are we doing this? Especially in the async context. That's the only thing that I can see right now. It makes me lazy in studying Rust. Oh, yeah, no, right? Because Rust actually is quite a bit more to Rust. It's a tool for so many problems. Python may be a suboptimal tool for. In many cases, yeah. Although what you could do is you can keep using Python, write the highly intense, computationally expensive algorithm in Rust, build a library that you can import into Python. There you go. There you go. You're also doing locking for none checks. NONE, back to C. Okay. Though, I suppose, if it's not none, okay. Exception is context is not none. Well, as far as I can tell, it still feels, I do that with C++ using nanobind for Python. Isaac, nice! That's very, very nice, very nice. You got to squeeze as much performance out of the compute as possible. If you need concurrency in Python, it's really bad because it can't really help with the thread safety. Yeah, it can't help with thread safety. There's the GIL, obviously in 3.14, they disabled you can disable the GIL if you want, the global interpreter lock. Although you run risks. I think from a Python perspective, the async that's available has to do with not so much compute concurrency. Although if you want compute concurrency, you can just use multiprocessing. Done, easy. There's no need to do threads, just do multiprocessing. And if you want, that's for compute concurrency. If you want networking or I/O concurrency, async I/O does that perfectly fine. And so you don't necessarily need all these locks. So that's the only thing that I can see here that I would say is just a little overly complex. Although I think it is a neat adventure in combining the two. And I don't know if you necessarily need it. I feel like it's possible to simplify this to not have to do all this extra. I think so. That's my take on it. Rust makes race conditions less of an issue, which is super nice, isn't it? I love that part about Rust. It's so great. It's so great. Yeah, it feels wrong. It does. It's a little bit wrong, I feel like, yeah. You want to limit certain things as the API shouldn't scale. Yeah, you can do that too. You can do that with I mean, a semaphore is just a counter anyway, so right? A semaphore is just like a fancy counter. So you could just do that with a simple integer if you wanted to. Since it's all right, it's just async IO. Let's see here. Different song. that song. All right, here we go. Processors are somewhat limited for compute concurrency, although if they work, it's great. Yeah, I know, isn't it? It's great. Multiprocessing is one of multiprocessing is a great, excellent library. Yeah, I love it. I love it, Savan. It's great. Using for lightweight processes that underlying backbone for the abstraction, I think it's great. Some limited for compute concurrency. Although, if they work, yep, I remember. All right, we just read that one. Sorry, Steven, if you have seen Superman Crystal, that can store terabytes. Oh, right, I remember that. Yes. I remember that with a 5D laser tech. I remember the pop culture, right? What is it? Science fiction. I remember that. Is it real now? Today, it's real. Async was born from the need to not deal with concurrency and concurrency primitives, as essentially apart from the main running loop, the code execution is interleaved. I'm down with that. I'm down with that, meaning that it's cooperative. Yep, there you go. Cooperative multitasking, yet no risk of variables being accessed and modified concurrently. That is my favorite way. That is actually how I built PubNub. We have 1 billion connected devices, right? Like I was saying before. We've got 1 billion connected devices. And in order to do that, we had to take the route of cooperative multitasking using just, keeping everything in line with that one master thread using async IO with interrupt-driven operations for event surfacing from the kernel. We used epoll. We used epoll to receive events for signals on IO. This allowed us to scale huge. Oh, wow, I didn't know that at all. Yeah, that's how we built it. Epoll, Linux kernel, and C. It's in C and Linux epoll kernel. That's how we did it. It's real, and it can store 360 terabytes in a small space. Wow, that's amazing. And we're getting close to 10K subs. Oh, aren't we? 8.5 already? Quantified Quantum, are you serious? No way. Wait. Let's check that out. I haven't even been paying attention. Let's check. All right, so YouTube, Steven. Here we go. Let's take a look. Where are we at? Oh, you're right. Look at that. Oh, we're doing pretty. All right, we're on our way, aren't we? We're on our way. Steven, what's your view on Bull MQ? I don't know what that is. Including Node.js, epoll. Yeah, epoll was most of async engines are implemented in. Yes, there you go. We're almost to 10K, you guys. Wow, look at that. Right? Just a stone throws away from 9, and then we're gonna hit 10 here pretty soon. That's amazing. What do you know? Thank you for mentioning it. We're getting close, you guys. We're getting close. Oh yeah, epoll is so important. Like a lot of the interpreted languages use threads that block for no good reason. Yeah. And we can just use kernel module epoll. Kernel module will take care of everything for us. We just have it schedule events, and then we can pause on the event loop and then wait for events to occur. And as events occur, we can just run through the same thread, which means that you get to use all the CPU and you're good to go. You can use as much of the CPU as you want. And you don't have to do all this extra context switching. It's just the best benefit for the most performance and the most use of the resources that are available to you. It's the best programming approach ever. And so when you have to do things like this, where you're locking and you're doing extra checking beyond the async primitives, it's a problem. Hey Kyle, how's it going? Happy Monday. Good to see you. Welcome on in. Happy to have you here. All right, so let's see if we can get back to our CNN. I really would like to make sure that we definitely get that going. I think we can make it work. I'm pretty sure we can make it work. Okay. So flatten. I think we got all this correct. So now the only thing we have to do is change the input. Let's hide this here. Close that down. Hey Xerxes. I don't understand anything, but I love this energy. All right, nice, thank you. Well, I'm glad to have you here. We're making an AI. Oh, all right, check this out. Here, let's undo this. Let's undo this really quick. Here, I'll show you. Check this out. This is what we're doing. Don't go anywhere. Stay right there. Here, I'll undo this. There we go. All right, so that should work. I'm pretty sure. We'll find out. All right, let's try to run this. All right, let's see if this works. Did we get it work? Okay. All right, perfect. So we're building a click predictor. Would love to watch this. All right, SAQ1000, we'll definitely watch it. So this click predictor, as you can see, all these green dots here on the screen, those are my clicks. I clicked there. And the yellow dot is where the AI is predicting the next click to occur. And it's learning over time. Obviously, performing is strange. It's not performing in the way I want to. So we're upgrading the model, the AI model, to be, instead of like an MLP, we're upgrading it to a CNN, a convolutional neural network, which will have context to positions. As it has multiple filters, as it passes through each of our inputs, will give us the ability to recognize a pattern, like a circle or a square or a rectangle. And it should see my pattern because I was doing patterns like this. I was like clicking on the screen in corners like this. So it should be able to predict very well when it sees a pattern like this. And right now it's kind of centering it, which means it's giving us an average. And that's not what we're looking for. We need a different pattern. So that's the plan for today's stream. If you're still here, Xerxes, there we go. All right, SAQ2000, let's check it out. Let's see what we got here.
I have a lot of components in either project.
It's a little bit long. It's a little bit long. Are there certain segments that you... Have you gone down here to find excuses for why the video isn't made good? How I built a watch from Cyberpunk. Ooh. That does look neat. I do think that would be neat to look at. Seems like yellow is an average, so not what we're looking for. Yeah, exactly. You're right. Exactly. We need it to be actually predicting where the next click is going to be, right? Sivan, you're 100% right. So it is currently the average. We need it to be the actual predicted output. So in order to do that, we need to convert our model from a standard linear MLP into a convolutional neural network, which is what we have here. So there we go. Let's do that. Boom. All right. So now what we got to do is we got to convert the input to match what the CNN is looking for, which I do believe is a multi-dimensional. It'll be multi-dimensional. So I just need to convert it. Quantify quantum. We got to vanish. Got some reading to do. All right. Sounds good to me. Sounds good to me. All right. Let me see here. Make sure we got everything in the right spot. We do. We have everything in the correct spot. So let's convert. Let's convert. Okay. So we need to go to the forward pass now. Where's our forward pass here? And then our features will be encoded. However, we need to add an extra CNN step. We need an extra CNN step. So let's do this. Def CNN encoder CNN self comma features. We need see, return features. Let's do a pass through here really quick. Features equals blah, 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 encoder CNN features. All right. So this is the extra step that we're going to do here. We need to change it into a... I need to print it. What does that look like? What does it look like? I forgot. Let's see here. I need to print it out. I need to print it out so I can see. I need to be able to convert it. Here's an interesting project. Let's see here. I'm just taking a quick peek here. I tried Wikipedia speedrunning using AI. What? I'll have to take a look at that here. I'll have to take. Tell us what it's about. I wonder why the MLP is not doing it. I'm wondering too. I feel like the MLP should do it. I feel like it should. And if we changed how we're doing different loss algorithm, loss functions, maybe a different optimizer, maybe we can get something that regresses a little bit better. Maybe we could. We're going to try CNN to see how we can get, because Neva recommended it. So we will try it out. We will try it out. Okay. 1 second. Click, click, click. Nope. What are we doing here? Oh, 1 second here. What? Oh, wait. One moment. I got to see what I did here. Okay. What is this? Oh, we don't need that. We don't need that. Yes. Okay. So I clicked some things on OBS and I had to check them out really quick. All right. Looking good. We're looking good. All right. Let's get back to... All right. So I need to print features. We need to call this CNN encoder, comma, features. Here we go. Okay. And then we do need to go back up here, and then I need to add these back here. Oh, hey, how's it going? What are we coding today? So we've got our click predictor. An AI that can see all of my clicks and then predict where I'm going to click next. Isn't that neat? I think it's pretty neat. I'm pretty excited about it. So that's what we're doing. And we did a pretty good job. Here, let's go ahead and what we can do here is s / with a that. Okay. And then here, I'll show you. Is that going to work, or is that going to have indentation issues? Okay, no, it's good. Okay, so here we go. So here's our click predictor. You can see all the green dots. That's where I previously clicked manually. And the yellow dot, if you can see it here, the yellow dot is where the AI is predicting my click to actually be. Obviously, it's not doing that great of a job. It's kind of moving around all over the place. 2, 3, 4 dimensional, interesting video. SAQ 2000. Interesting. We'll have to check that out. We'll have to check it out. Okay. So, la. Okay. Yeah, essentially, and we want to make it be able to track predictions as well as it. Put it in Discord. Yeah, that SAQ, that would be good. If you put it in Discord, then we can have it for later. Definitely put it in Discord. Okay, let's see here. I really didn't know you can pull inside to outside. What does that mean? What does that mean? Okay, so so here's what we're gonna do. We're gonna get that, Control V that, close that. Okay. So now I need to encode it. Wait. Okay, so where is my scene encoder? All right, it's a tensor. So it's already a tensor. All right, so it is a one-dimensional and 1, 2, 3, 4, 5, 6. Okay. So what I don't even know what the input on a CNN should be, other than it needs to be a 2D input, I think. You don't use Discord, but if I am annoying, I'll stop posting. All right, sounds good. No worries. I just wanted to watch what you were sharing. Got it. I meant about the video, like it's possible to put inside outside. The more you know. The more you know. I didn't know. So I need to see what does the input shape need to be for this. That's what I'm wondering. All right, so let's see. Let's sort of search around here. Don't need that. Close that. Okay. Net print net. Okay. Let us see. What? Let me see. What does input shape need to be? Obviously 2D matrix, right? What solution? Okay. The input is a you say a batch holding 2D tensors. So we need a 2D tensor. Okay. And could it be any 2D tensor? Or does it have to be 28 by 28? Like, that's what I'm wondering. Like, what does our specific setup need to be? Tensor to tensor your matrix. Okay. Well, yeah. Okay. Yeah. So we just need to make it a matrix. You need to first pick your resolution. There need to be a project to hidden and project from hidden. Right. Okay. You want to specify the size, but it's somewhat tolerant to the size. Is it really? So I can just be any size 2D matrix. Then, if that's the case, let me just do something like this really quick. See, for feature and features. See, let's see, new, what do you call this? 2D tricks equals blurb. I suppose, all right, we'll do, we'll go like this. Feature, well, how about this? Features, there we go. That should do the trick. Okay. Let's see if that's different. I would run for any size. Okay. Technically, but the model won't perform well if the train and test sizes are very different. Got it. Okay. Okay. Lock in, bro. We're locking in. We're locking in. We'll see if we can make this work. I'm pretty sure we can. All right. So that is just going to copy the features. And then maybe they'll have... now it's a two-dimensional matrix. Here we go. So... although, wait. We can't do it like this. We have to say, we have to retorchify it. So we have to do a detach features. So this is the problem right here. Can we do this? See if we can do that. Although I don't know if we can. Let's see. Tensor. All right, this will be here. Okay. That would be really fun. They're really. Oh, sorry. Yeah. Okay. Let's see. I feel like. Oh wait, we can't start with letters. All right. Let's call it matrix. Okay, so that definitely... Okay, so what does it want? What does it want? CNN encoder is a tensor. And then where did it fail? Only one element tensors can be converted to scalar. Okay. So, got it. Okay, so how do we go about so that I suppose what we could do here is we won't make it an tensor immediately. So instead, we'll reorder this. So like that. No, we can't do that. That won't work. Let's see. Features equals features dot. Actually, let's say matrix equals features dot. Here we go. We'll do that. Okay. That should be fine if we do this. Maybe. We'll figure it out. It's still not happy about that. Why? We'll figure this out here. Train forward encoder. Did we where's our forward at? Oh, okay. So forward, features encoder, then CNN encoder. Let's see if we get a different error if we move that out. Okay, so we do expected 3D unbatched or 4D batched input, but got input size of 6. Okay. So this is the shape that we need to convert it into. So let's copy and paste this. All right. Comfy, but we got a size of 6. Okay, yeah. Okay, we obviously, right? So that's what we're doing. That's what we're doing. We're converting it. So features that detach print matrix like this. There we go. That was the problem. I think that was the problem right there. We figured it out. That was the problem right there. Okay. Oh, good. Okay, now we're making progress. Good. Okay, so where was our outputs here? Okay, so encoder, tensor, then we decoded it into a NumPy. Creating a tensor from a list of indie array is extremely slow. Don't worry, it's a very small list. Please consider converting list to a single NumPy indie array with NumPy array before converting to a tensor. Got it. Okay. So where's that at? We will make this happen. Convert the list to a single indie array before converting to a tensor. Okay, so we just have to wrap it. Okay, I've got an idea. Before we tensorify it, like that. Then we convert it. NP dot array matrix. So if we do something like that, then that should be fine. You shouldn't need NumPy for anything. So Pytorch, as far as I understand it, really likes to use NumPy when you're converting between a torch array and to like a CPU array. I think it really likes that. As far as I can tell. Should I learn Python or Rust? Oh, Savior 34. Python first and then Rust. So Python and JavaScript are the world's most prevalent languages. Those are the great languages that any engineer is expected to know as a default when you're entering into industry. So Python is on that list. Rust isn't quite there yet from that perspective. However, Rust is the best language. In my opinion, hands down, Rust is the best language in the world from its capabilities. Let's make a PubNub clone. We'll reverse engineer Steven's code and find his hidden system and he was talking about. And then we can rule the world. Kyle, if you're able to do that, yeah, you'll be able to do good. Yeah, because I've got connections. You guys have got connections. You could, if it's inefficient, you're making weirdness around gradients, which is very scary. Like try always avoid to numpy. Got it. Is there a way that I can manipulate the torch array? Because right now it says it does not like it unless because the problem is I've already converted it to a torch array here. I converted it to a torch array. And what I need to do is, this is the normalization step. So I'm doing normalization here where it takes the screen resolution and the coordinate of the pixel or the click coordinate, and it converts it obviously from 100 by 100 down to 0.1 to 0.1. So we're normalizing it here. And we need to keep that. Obviously, it's got to be kept the same, that normalization. And then I'm just... Steven is a connection wizard. Ah, yeah. There you go. We'll maybe do some network programming later. I think that'd be also fun. Yes, it's NumPy functions exist in Pytorch. Pytorch is an extension. It's an extension. Let's see if this works here. Let's see if we got rid of the warning. Okay. We got rid of the warning. Hey, there we got rid of the warning. Ahmed, thank you for your subscription. Thank you for subscribing. All right, let's tell you about what we got going on here. So I'm CTO of PubNub. We're a globally distributed messaging infrastructure. We power a lot of the internet. If you didn't know about this, you probably already used my technology. Have you ordered any food for on-demand delivery? Do you have a smart TV? Have you played multiplayer games? Do you have apps on your phone that have built-in in-app communication? You've probably used my technology then. We've raised 134 million. We're Series E. We've got over 1 billion connected devices. Here's one of them right here. Here's one of the devices. And I've also got 68 patent claims, and I've been in the air for a quarter of a century. A quarter of a century. Crazy flex, isn't it? I know, right? We've been doing this for a while. And so I'm very happy to bring all of my experience, and I will help where I can and tell you what worked for me. I'll tell you what worked for me. So if you have any questions, let me know. This stream will be focusing on AI, and in the future, we'll be doing even more AI. And we're coding from scratch. No helpers, no code completions, no Copilot. 1 billion connected. Think about it. It's a lot. It's a lot. You're really that guy. I'm really that guy. Yeah, that's me right there. You can see I'm on LinkedIn too. You can check me out. I'm gonna add you on LinkedIn, dude. Do it. All right, I'll do it, and then we can. I'll click the button. I'll click the button. Let me know when you're there. I will click the accept button. What's happening in the last attack? Good to see you. So Neva, you're saying Torch is actually more convenient because you can got more stuff in the indexing. So what I want to do, Neva, I definitely want to do that. I'd much rather do that. I would want to manipulate the tensor in Torch, not having to convert it to NumPy and then back into a tensor again. I want to do that. Is there a way to do it? I will try. I'll try the best. I'll try it again. Because it was giving me errors before when I was trying to do basic manipulations. Like list comprehension. I was trying to do some list comp. Sometimes you type Pytorch over NumPy just because, I want to use the torch. I want to use the torch. I saw Tesla Robot was doing construction work even at the job. Are you serious? We're in the future, you guys. We're at the very beginning of the future, aren't we? We're at the future. Pretend it's a NumPy array and run all the functions. Okay, I will. I'll try that, Neva. I'll try it. The last attack, that's amazing. Hey, Steven. Happy Monday. Hey, Kyle. Kyle McDermott. Welcome on in. Happy Monday. Good to have you here. It almost always works. Okay, I'll try it. I'll try it. Done adding. All right, here we go. I will add you. Let me see here. I'll go LinkedIn. I've got another window open here. I'm gonna make sure I see you here. Let's see. Here we go. Okay. La la la. Where are you at? Where are you at? Okay. Invitation. Oh. Okay. Is it? Are you Yi Yent Ong? Here, I'll zoom in. Here you go. So here you go. Is that you? Are you Yi Yent Yang? Let me know, and I'll click the accept button. Or are you? Are you Ahmed? Are you this? Oh, sorry, you tap. Okay. How you raise 100+ million for PubNub? I know, right? Kyle Duran, isn't it crazy? It's because we got revenue and we're making money, and that's how you so like if you've got revenue, you're making money, then you can raise money. It's easy. Ahmad, all right, here we go. Accept. There you go. There you go. Let's see here. Where did that go? All right. So Ahmad. All right. Here we go. Where are you at? Where are you at? 1 second. Also, here we go. Oh wait. Where'd you go? Where did you go? Did I click on the right thing? 1 second. 1 second here. Where are you at? Let's see here. La, la, la. I want to make sure. I want to send you a message. Well, send me a message so it pops up. Send me a message. I can use computers. I definitely can. I just lost you. I just lost you somewhere here. I'm sorry about that. Sorry about that. Yeah, send me a message. Send me a message because we just connected, and then I can reply to you. Send me a message. All right. So, oh, Yi Yin Yang is okay. Is you too? Okay, I'll add you too. I'll add you too. All right. Let me go back here. All right. Here we go. Send. Oh, I see what's going on. I need to make the window bigger. Okay. All right. Here we go. Message. All right. There we go. Hello. Hello. There we go. Sent you a message there. Sent you a message. All right. And then we will grab the other. We'll also grab here. Also say. All right. We're good there. Okay. Where are we at here? Go back to network. And then. Here we. Oh, wait. Where'd you go? Here we go. Okay. Accept. All right. Gotcha. Gotcha. And I'll send you a hello message as well. Hello. All right. We did it, you guys. We did it. We connected on LinkedIn. Isn't that crazy? Isn't that amazing? It's how things happen. It's how it works. Okay. What we could also do is use Tinker to convert the screen into a %. That way we wouldn't need to convert it if this RN doesn't right now doesn't work. Torva, that could also work. We could try that. Sorry for interrupting. Hey, no, it's all good. Thank you for interrupting. I send you a connect as well. Neva, you did? You did, Neva? Because why not? Let's do it. Neva, I want to be connected. All right, so I definitely want to be connected with Neva. All right, here you go, Neva. Okay, let me see here. Where are you at? Oh, there you are. I see you. Okay, connect. There we go. There we go. Hey, Neva. All right. We're connected now. All right, check it out. We're connected on LinkedIn now, Neva. There we go. That's us. That's us for real. LinkedIn is using PubNub. Savon, someday maybe. We'll see. Yay, we did it. Let's see. Heart. There we go. Okay. All right. Let's bring this back window over here so we can get everything all organized back up there. Clicking the buttons, reorganizing the windows. Perfect. All right, let's see the chat here. I've Kyle McDermott. I'll have to send you a message about series funding. Sounds good. I'm also curious about series funding. It is venture capital where they buy equity in your company in exchange for dollars that you want to spend to grow the stock value. That's what it is. That's what it is. Are you looking for cybersec interns by chance? Currently, we have a couple of open roles, though not for cybersecurity right now. I connected to you. Did? All right. Let me see here. Let me see. Let's jump back over here. Let's jump back. Let us go over here. Clicking on the button. All right. Here we go. Scrolling. Wait. Who? Kartik. I connected you. Here we go. All right. Kartik. All right. There we go. Connected. We connected you. Now we're connected. Kartik as well. All right. We're connecting a lot today, aren't we? There's a lot of connections today. All right. Kartik. Hey. Okay. Where is... Let me send you a message as well so we got that going. Where was that at? Okay. Message. Here you go. Message. Excellent. Hello from YouTube. There we go. Hello from YouTube. All right. We're connecting so many connections today. This is great. This is great, you guys. All right. Let's see if we can get back to our convolutional neural network. All right. It is here. Okay. So Neva says keep it inside. Keep it inside. So can we do this? Can we do this? Is my... I don't know if we can. Can we do it like this? Or do we have to... Here. Okay, so we know this works. We know this part works. So matrix is going to be equal to features. Matrix is going to be equal... Here, we'll just comment this out for now. And then we need this. It needs to be a torch array or a tensor. So can we do this? Does it have to be like this? I'm trying to figure this out. And then we need to torch tensorify it again. Is that going to work? I don't know if that's going to work. See, like, we gotta come up with some other approach here. I suppose we'll think about it. We'll think about it. I wrote some short stories that show advanced storytelling on my LinkedIn, Steven. If that kind of interests you, check it out. Or I will. I do. I think short stories are great. You need to have a very, very focused loop on the story, the hero's journey, right? The writer's journey. Got to be a very focused loop on the story, especially when it's a short. Makes it easier and harder at the same time. Makes it easier, more difficult. All right, let's see if that works, or is it going to give us an error? Name NP is not defined. Did you mean NN? Oh, okay. So we don't have that. So numpy. We have to do that later. To do if we use, we need to import numpy. I'll know what it says. Hey, how's it going? Clement just hopped to see what we're doing. Oh, what we're doing. All right. So what we're doing is we're converting our AI that was a click predictor. It was a click prediction AI to see where you were going to click next. I gave it a whole bunch of clicks. We recorded all the clicks and we added a heat map to visualize the output over time as the model is training. We found that a standard MLP was not doing what we wanted. So we've converted it to a convolutional neural network right here that you see on the screen. So this is the convolutional neural network right here. What we are doing currently is we are transforming the encoding to fit the right input size for the convolutional neural network. That's what we're doing currently. That's what we're doing. When we're getting there. We're getting there. It makes it happen. We're making it. Can you show an example? Yes, I can. I can show you an example. And it will take 1 second. It'll take 1 second. All right. 1 second. All right. We have to undo some of the things in order to get to work right. La la la. La 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 la. Return features. Okay, that should work perfectly fine without causing any errors. Let's see if it works now. All right. Did we get it back? I think we did. All right, here we go. There you go. This is what it looks like. Right here. You think this would improve the results? Yes, I'm pretty sure. So as you can see here, here's all our clicks, all the green dots. Those are our clicks. That's me actually clicking on the screen. The yellow circle that you see here is the output, the predicted location of the next click. Obviously, it's kind of not really working, as you can see. And the red is a trail of the history of all the predicted outputs. So what we're trying to do is get it to actually predict the outputs. So there's a lot of things that we got to do. We're gonna do more than one epoch. We should do batch training. We got to randomize the inputs. There's a whole bunch of things that we could do. Right now, we're trying just a convolutional neural network. So that's the one thing that we're doing today. So let's close that off. And I'll just go here. Sorry, I changed up the music there. That was a bit getting weird. Okay. Okay. Let's go back to this. Okay. Restoring. Here we go. Looks good. Okay, so now we're back to normal. Features. This will give me an error. I think this will give me an error right here. This line, this will give me an error, I think. I'm pretty sure, although I don't know. We'll find out. Yeah, it doesn't like that. Only one element tensors can be converted to Python scalars. So instead, do we do this? Because is that going to work? I don't think that's going to work because that's also going to be a problem there. Same error. Same exact same error. Getting better. Oh, okay. We're making improvements. We're making improvements. It's happening. Things are happening. Okay. All right. Progress. Making progress, you guys. Let's keep going. Let's keep going. Let's see what else we can get here. With this, you can create a game villain. Wait, a villain with teleportation ability that can predict the next place to attack very quickly just for fun? That would be a very difficult game. It would be able to learn all the players' movements and destroy them every time. It would be like the ultimate AI. Anything that you try to do, don't worry, the AI is going to figure it out. You try to play, nope, the AI will always win. It'll always win. How do we go about doing this? So matrix, let's see, plus equals matrix. Let's see what that does. Obviously, that's not going to be the right shape, though. I'm trying to turn a 1D tensor into a 2D tensor. And Neva says, the fact most NumPy is just compatible with NumPy is so useful. Like Google copied this for JAX, which is their accelerator for AI, right? An AI accelerator pipeline. When it went even more all in on it, did it? NumPy is really great. I enjoy it. I feel like that's what the native Python arrays should be. Oh, Pytorch, got it. Pytorch. Got it. Well, I'm still in love with Python or Pytorch or NumPy. I'm still in love with my happiness with NumPy. Pytorch is also great. All right. So how do we convert a 1D Pytorch, like Pytorch compatible with NumPy? It's very compatible. It is. It's very compatible. I'm enjoying it. It really likes it. It's like its favorite. It's his favorite. So how do we do this? Okay, so where is the output look like here? I need to scroll up here. Okay, encoder matrix. It's the same thing. It didn't do anything. It just, it increased it? Tensor, no, it didn't even add. It didn't even modify it. It did nothing. Or did it? No. Okay, it did. Okay, I see. So it did a math operation to add it. But I want to, I get the math operation. I see what I'm doing. It's just that I want to convert a 1D tensor to a 2D tensor. Yeah, so anytime just try NumPy and see if it breaks to do something else. Is Google kind of abandoning their TensorFlow? That's a good question. Are they? Are they going all in on Pytorch? I don't know. Because TensorFlow is great, especially with Keras. Very easy to use. Very easy. I very much love it. Okay, let's see here. Let's ask for some help. Okay. How to convert Pytorch 1D tensor to a 2D tensor without breaking into non-tensor like array or NumPy. Is that possible? Can we do that? Is it possible? Reshape. Okay, so there's a reshape command. I should have known that. I should have known that the whole time. All right. So let's go to 2 by 2. Let's do a reshape. Okay. Equals features.reshape. And then we will call this 2 by 2. Maybe. So let's see what that looks like. Okay, let's see what this looks like. That did not, and CNN code, it did not reshape it, did it? Matrix, reshape, features, CNN matrix. that didn't even do anything. Wait, shape 2 by 2 is invalid for input size 6. Okay. Where's our input size? Oh. Interesting. Okay. Okay. We'll be able to figure this out. We'll be able to figure this out. So we made progress. We made progress. The only thing is this reshaping seems to, hey, Key Nova. Yo, is this guy coding? We are coding. We're coding from scratch. This is dope. Hey, thank you for joining in. Happy to have you here. Yeah, we're coding from scratch. We are coding without the help of an AI code assistant like Copilot. We're also not using, generative coding, except for we'll Google things. Nice, isn't it? Yeah, I know, it's great. So we're actually coding. All right, and so not even a Copilot. So what about cellular automatas? Time direction being the opposite of the outside observer, where the future isn't fully determined by the past. What are you saying, Kyle? What are you saying? Hey, I have a question. How do you determine the right balance of filters in a CNN? Okay, so I know about this. So the number of filters is based on when it's sampling the picture, right? So you've got a 2-day here. Let's take a peek here. So let's walk through. Let's clear the canvas here. Let's clear everything. Reset canvas. Where's that at? Live export. Reset canvas. Here we go. Okay. So let's see. This is number 3, 2. Here we go. So here's a picture, right? The picture has got a whole bunch of pixels, right? Pixel, pixel, pixel. And I should probably make the pixels the same size so that way they're easy to see. Let's close that. Let's copy this. Copy, paste. All right. So here's a picture, right? And we'll make it like a really simple picture. So it is a picture with a 3 by 3 picture. Very simple, very small. Okay. And when you're selecting how you're sampling your filters, essentially you're going to take a picture, or you're going to capture these 4 pixels here, and that's going to give us an output, a new output right here. Whoops, undo that. Let's click. A new output down to a single new essential value. And this is going to be running through with one filter, right? And then you sort of do a step. So then you go to the next 2, and then you go to these 2 and these 2, and then you're done, right? So it's stepping through these pictures. That's one filter pass. And so that'll generate output from one of the filters. And then you'll have another filter that has a whole bunch of other random weights. And then you do the same thing again. And do it again and again and again. And then you get this collection of outputs that then you can collapse or pool together. And so when you're deciding on the number of filters, it really depends on the complexity that you're looking to achieve within the picture. What are you trying to extract? What's the dimensions? Is it a very complex scene or is it a simple scene? And you're good to go. Best YouTube page tried of AI slop and genuine coding session. Yeah, genuine coding. This is it. This is it right here. We're doing it. We're making it live. I've always liked coding. Me too. Google it. Wait, Google cellular automata. All right, I'll try it. Cellular automata. Let's see here. Discrete abstract models of computation on a grid of cells where each cell changes state over time based on simple local rules applied simultaneously across the grid, producing complex emergent patterns from a simple beginnings. This is the game of life, right? The Conway's game of life. That's what it's based on. And it's like sort of a genetic style algorithm where you've got just a world with a few set of rules and you run iterations. And then you eventually have like a set of winners. That's the idea. Mr. 8long, how's it going? What can I say? What can you say to build and make money? Well, if you build an app with a product, that's a really good start. Well, it makes a lot of sense. Thank you. Yeah, happy to help. I send a connection on LinkedIn. All right, Clement. All right, here we go. Let's pull you up on LinkedIn. You guys. All right, where are you at here? LinkedIn. All right. Let's bring it up. All right, go to requests here. All right. And I see Clement. I see you. Here you are. Here we got Clement, you guys. We got Clement. All right, accept. All right, there you go. I'll send you a hello message. It's good to have you here, Clement. All right, message. Okay. message. Wait, I just clicked it. Oh, I have to zoom out here. I have to zoom out. There it is. There it is. Hello. Hello. From YouTube. All right. All right. We got you connected. We're connected now. Good to have you. Okay. So let's see if we can get back to here. You have emergence, and that's the important part, emergence. So Kyle, thank you for bringing that up. That was the word last stream. I was trying to remember so hard. I'm like, what is that one word where it means where something happens as a matter of consequence based on the set of the rules of the world? What does that word mean? And like, I was trying like, when you have like a really big AI and you're training it as much as you can, and there's all of a sudden these capabilities that you didn't train it on, but it suddenly has the capability for. The word is called emergent. Kyle, thank you. Thank you. That was the word I was looking for all this time. Any area I should focus on, anything from experience where you see future going. Python, JavaScript, AI, big data, those are great. Security, security is often very boring. It could be exciting to some people. It is very boring for a lot. And I tell you what. Let's see here. Let's go to 100. Okay, event horizon. Sounds good to me. Security is the biggest spend in tech, other than AI right now, right? So AI and security. AI and security, you guys. Okay, so let's see here. Let's get this back over here. Pulling in the scenes. And let's see if we can get our CNN going. Okay, so we're making progress. We did the reshape. Let's see. How do we say this? All right, so it's a tensor with a reshape input size of 6 is invalid for input size of 6. So what if we did this? What would that do? Is that going to make a difference? What if we did 6? Let's see what that does. I want to find out. 2 6 is invalid for 6. Okay. How can you accidentally predict a user's click when emergence exists? That's what we're trying to do. Right? Okay, good point. Like it's all intentional at this point. We're very much intending to predict the user's click. However, what we did was we created like a global, some sort of very large model that was able to predict some or just track user input, and then it was suddenly able to predict a user's next click. That would be an emergent behavior because it wasn't necessarily trained on it. However, it became capable of doing that regardless of its training. I think that's really neat. I think that's very neat. I love that. Emergence is the word. It's the word of the day, you guys. Emergence. Okay. 6 by 6. What if we do that? Is that going to work? I don't know. Invalid for size of 6. Okay. What if we did not 6? What if we did 2? Okay. That's really cool. I think it's really neat. Input size of 6. It still says 6. Weird. Why does it say 6? Does it say where it's at? Which one? Line 182. 182. Oh. Really? Okay. Reshape. Invalid for input size 6. Okay. 2 by 2. Obviously, that's going to be fine. Or we could do 2 by 3. Although, I think it's got to be 2 by 2. Because that will make it into a square. Right? It'll make it into a square. Will it, though? No, it makes it into a rectangle. It's still a rectangle. Let's do 2 by 3. Okay. Yeah, we're not predicting the click itself. You're replicating the user's behavior. When it comes to clicking, yes. When it comes to clicking, you got it. It's entropy, you guys. It is. It's entropy. It's all the entropy. All right, expected 3D unbatched or 4D batched input. So we need to do something like this. Can that work? I don't know if that can work or not. Calculated padding input size per channel 2 by 3, kernel size 5 by 5. Kernel size can't be greater than the actual input size. Okay. Because our input size is very teeny tiny. I suppose what we need more data. We need more data. I suppose we could make it more. We could make it a lot more. Let's see if we can make it a lot more. Let's change the input data. Where's that at? Where'd we put it? Where'd we put the input data, you guys? Is it around here somewhere? I know it is. It's around here somewhere. Here it is. Okay. What I need to do is create an input size. So let's see if I can. I want to make that more prevalent. Okay. So where is this at? Well, it's just a function called prediction. So predictor.train marker game. So predictor. Let's do this. Let's do it on the predictor. Let's see here. Where is that at? In predictor. And then we'll say self dot, I guess, size. How about length? Input length, length equals. Currently it's 6. Right? It's currently 6. So let's make it more. let's make it a bit more. Let's go 6. Let's see, 2, 4, 8, 6. Let's do 8. Let's do 16. So that'll be the input length. Okay. And then is that? Yeah, I think we'll do that. So that'll be predictor.input length. If you could connect quantum particles, it would work perfectly. Maybe. Maybe. Honestly, yeah. I mean, kind of would never reach absolute certainty. We would only approximate it. We're an approximate. That's right. That's the best we can do is get fairly accurate approximate. Fairly accurate approximate. So this needs to be, what is it? Predictor dot length. Let's see. That's a lot of text. It's just a lot of text. Predictor.length sounds good to me. We'll do this -2, right? So you always got to do that negative -2 and then -2 there. That should do the trick, I think. I think that should be. Oh wait. Here we go. Wait. +2. I think we have to do that. Wait, let's undo that really quick. Okay. So yeah, so length is 6. However, we say -2. Number of chords has to be 16. We'll say 18. So you need to increase. Yes. Okay, so we did it right. 2, subtract 2. There we go. So that should do the trick. So that'll give us a lot more data. Okay. You have made a game of life in Python, Stephen. I've not made the game of life, like Conway's. I've not done that before. Some quantum algorithms can be absolutely certain because phase state is a matrix. Matrix mults. Sometimes you can get 1. There is not a very common approach because you're criminally underutilizing. What are we criminally? Wait, we're underutilizing? You should what? Okay, so that is a lot more data now. I think I should be fine. I think that looks good. And then I guess bring that back up to 6. I don't know. We'll find out. We're gonna mess with it. Okay. Oh. It's not prediction. It's predictor. There we go. Predictor. There we go. Okay. You should make. You should. You should make the game of life. Gotcha. Related to something else. DW. Got it. Okay. Sounds good. 1, 2, 3 is invalid for input size 16. Oh, right. Sure. Okay, so 16. We need to make it something that's divisible, right? Okay, so reshape. Here. Okay, so 1. We'll do 4 by 4. That should be 16 friendly. Okay. Calculated padding input size per channel, 4 by 4, kernel size 5 by 5. Okay. So we are a 4 by 4. A 1 by 4 by 4. Right? So, which would get a 16, and the kernel size is 5 by 5, which is too big. So we could do can we do 3? Does that work? Okay, let's try that. Calculated padding, input size, channel 1 by 1, kernel size. Okay. You can do a lot with it. It's very cool. Nice. That would be a lot of fun. I would enjoy that. That would be a lot of fun. Are we still live? Yeah. Oh, we're still live, Savan. We're still live. We're doing a long stream today. We're doing a long stream. Can we use a genetic algorithm for this? It will improve each phase and might perform better. Yes, you're absolutely right. We could add the genetic onto it. Oh, K Neva. Thank you for the 30 joules. I just saw it over there. Thank you so much. Appreciate it. That was amazing. Whoa, what are you doing? Thank you for the 30 joules. That's very appreciated. That's very kind of you. Thank you. And thank you, Party Poppers. I know, right? I just saw the 30 joules show up there. Oh, I didn't know. No problem, Kineva. Thank you. Happy Monday to you. I hope you have a great New Year when it happens here in a few days. It's coming around the corner, right? Coming around the corner. You're a chill guy. Nice, cute. Thank you so much for saying. Thank you. Yeah, we do a lot of fun things here. We're focusing on AI. You like this live? Nice. That's great to hear. That's great feedback. That's great. That lets me know that we're doing something right? That lets you know we're doing something right. We're making progress. Thank you. Same to you. Thank you. That's really awesome. We're trying to get our input size to the right shape. So the kernel size can't be greater than the actual input size. Yeah. Honestly, it's so much fun. Nice. That's great. That's great to hear. Thank you, guys. Thank you so much for being here. This is awesome. You're having as much fun as me. I see YouTube only has negative features for mods. Moderators should have positive ones too. Oh, that's a good idea, right? Because a moderator has the ability to, time out or, scrub some comments. It doesn't have any positive ones though. Oh, it's neat. I didn't even know about that. That's a good idea. YouTube, you should do this. Pin a comment. Oh, there is a pin comment feature. I know that. I know there's a pin comment feature. Kyle, I've done it before. What comment should we pin? If there's I know I can do it. I've done it before. Here, pin a comment, etc. There you go. We just pinned your comment. We pinned your comment, Kyle. Okay. So, what is? Thank you for the like. I saw the little floaty heart icon there. Yeah, but can mods do it? Oh, got it. Oh, yeah. It seems like it might be just the streamer. Seems like just the streamer. Okay. So we need to figure out how to get the right. So we're messing around with the shapes here. So 4x4. What if we did 2x2? What does that look like when we do that? Okay. All right. 1, 2, 2 is invalid. Right. Okay. It seems like that should be valid. I mean, it feels like it. How about 2x4? All right. 2x4. We'll try that. It's not valid for 16. What if we do 4x2? Something like that. Is that going to work? Nope. Don't like that either. Okay. How does one make a chat disappear as watching on the phone and AI want to look closer to the code? Savan, what? What do you say, Savan? How does one make the chat disappear as watching on this phone? Oh, so you can look at the code. Got it. So here, got it. On the mobile, okay, so Kyle's got it. Live chat settings, 3 dots on the top right of the mobile phone. And then, so you click here. Let me see if I can find it as well. Click here. Let me go live. Let me click on the live. Nice. Maybe. Okay. Wait 1 second. Is this live now? Yes. Okay. So actually click. All right. It's not videos, home, live. Okay. Here we go. 3 dots. And it says live chat. Okay. There's, I don't know if you can see this. I don't know if it show up, but there's like, right there, there's like a little, it says live chat right here. Right here. And I think you just click that button on the live chat button, and then it will disappear. The chat will disappear. Let me try it. Live chat. Yeah, there it goes. All right. Hey, it works. It works really well. Excellent. 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 Okay. And then, yeah, also, yeah, Torva. Yep, it was also Twitch. You can also do that. That also works too. The horizontal stream. Yep. On Twitch. Twitch. Phase state is a matrix mult, means quantum logic is deterministic math. We multiply vectors by matrices to calculate states, but measure remains a probability. Had to search some things up. Yeah, you definitely did. Twatch. Purple. Exactly, purple. All right, so 4x4, it seems to be happy with 4x4. We're going to stick with 4x4. The only thing we have to do, though, is now the kernel size is... Well, what if we... did 5 by... Why does it say kernel size is 5x5? That's what I want to know. How do we change the kernel size? So it says calculated padding input size per channel 1 by 1. 2? 5 by 5 again? Okay. What if we did 10? Let's go the opposite direction. Now it's 10 by 10. What's going on? 8. 8 by 8. So is 5 by 5 like the minimum? Is that the absolute minimum? Okay, given the input size 611, calculated output size 600, output size is too small. What if we did 2 and 4? What I need to do is see what that conv2d is going to be. Given input size, it's too small. Okay. I need to look this up. We need to look up this. See what that is. Okay. Let's do copy paste. Let's read the docs. Okay, in channels, out channels, kernel size. Yes, that's what we're doing. Kernel size. And the kernel size, what is that? Is that the, is that stride padding, dilution groups, bias, padding, device? Okay, so stride is going to be 1. Always fine with stride 1. Padding 0. Padding should be 1, right? I think. It's smarter. Oh, 1 second. I gotta click some buttons over here. Clicky. All right, there we go. It's smarter than you. Kyle, what do you mean? I sent a video in Discord. All right, nice. Let's see here. Discord. Oh, it'll trick you. Okay, Kyle, it's smarter than you. We'll trick you. All right, let's see. We'll pause the music.
It'll trick you. Because like, if you have a system that's smarter than you, right? Hypothetically, we can argue about whether this is possible or when it will happen. But just like assume such a system existed. Assume you have a system which it's smarter than you, it's smarter than all of your friends, it's smarter than the government, it's smarter than everybody, right? And you turn it on to check whether it will do a bad thing. If it does a bad thing, it's too late. It's smarter than you. How do you? You can't stop it. It's smarter than you. It'll trick you.
Well, I mean, if you have the power switch, and if it's smarter than you, and then you give it the inability to access external networks, right? You do a closed air gap, and then you turn the system on, and even though it's air gapped, and it tries to do a bad thing, then you turn it off. And you're good to go, right? You turn it off. That seems like that could work to me. That seems like it could work to me. That dude was deep in AI. Really? Deep, like very deep? It seems like it. Stride kernel size. All right, let's learn more about the kernel size. Size of the convolving kernel? Thank you. That's the perfect. Exactly. All right. Kernel size 0. All right. Stride 3. Stride 2 with square kernels and equal stride. So is the kernel the view on the window? That's what I want to know. He had credentials. He's saying what he meant. What he's saying we can take with like a really like we know what's going on there. We know. Can I do a conv1D instead? Conv1D, a 1D convolutional over an input signal composed of several input planes. So can we do a conv1D? Maybe we can convert this to a conv1D, and then we don't need to double encode. We could try that. What is it called here? In channels, out channels, kernel size. So you still got to have that though. Still got a kernel size on it. Okay. And we're making progress here. Okay. And like imagine a 7-year-old has a button you absolutely need them to push. You won't necessarily be able to make them push it, even though you're smarter. Always a great moment to discover grammar mistakes. Reminds you of the author was human. Yeah. You could see that. Oh, those are great moments. Great moments. It brings a little bit of joy. That's probably like one of the things that'll be missed. Once the AI gets so good, it won't ever make a mistake. Well, still streaming? Yeah, Quantify Quantum, still streaming. I know, we've got a long stream today. We'll see if we can get things going. Got to pick back up the new year. And then we'll go back to normal streaming hours starting tomorrow. Normal streaming hours. Let's see here. 1D conv would make it not good about reasoning the space. You need a 2D. Okay. Thank you. I love food. Hey, how's it going? Welcome on in. Good to see you. Well, good to have you here. All right. So Neva, good to know. We will not use 1D. We'll stick with 2D. So 1D is same? Is it? I don't know. So we're still trying to get the input data to shape up, right? We're trying like a 2D. So yeah, we've got a 2D right now, and what we're trying to do is just get the data to fit in the right spot. However, we need it bigger. I think we're just gonna go bigger input. There we go. We'll do bigger input. So let's try that and see if that works. Okay, 4x4 invalid. That's fine. I can do that. Reshape. No worries. We'll do 8. Let's try 8. What coding language? This is Python. So see, now we've got a kernel size that's not the right size. So then how about this? We need a 5x5, so we'll do 25. 25. 5x5, reshape. 5x5. There. It'll fit now. It'll fit now. I'm pretty sure. We'll find out. Yeah, we're doing Python. That's what we're doing today. I'm so inclined to buy the membership. Is it cool? Well, you know what? That is absolutely optional because all of our live streams are video on demand. They're free forever. They're free. There's only it's only if you're interested in donating, essentially. Donating to the stream, donating to the channel. Essentially at this point. There are some pre-scheduled videos that'll get released over the next 6 months or so. If you want to access those, they're essentially edited versions of the live. So what you see right now, they're edited versions of the live. And you will get unlimited access to those if you do the membership. So if you buy a membership, then that's what you get. You get access to those. And you also are saying, hey, this is a great channel. I would like to buy a membership. So if you want to do that and you appreciate the channel, then hey, thank you. Thank you so much. Otherwise, happy to have you here. It's great to have you here. You can use Pygame if you are making a game. You can. Legend. Thank you, Legend. Thank you. You're the legend. All right, so let's see here. I think this will work now. We've got it 5x5. So, hold on. Oh, our shape negative is invalid. Oh, right. It can't be 25. because, okay, thank you for the likes, you guys. Thank you for the likes. It has to be 26 because it's got to be an even number because the encoding requires it. So right now, 5 by 5 is invalid for input size. Okay, so how do we get to 26? 12 for 13. 13 works. What else? 26. Let's see, reshape. What are you working on? So we've got a click predictor. It's an AI that learns a click pattern. We've built an MLP that sort of worked but didn't really. We are converting it to a convolutional neural network. And we are at the point where we want to get our click coordinates, or XY coordinates, into the conv. And that's what we're currently struggling with right now. Because it seems to want certain shapes and sizes, which we've gotten it to kind of closely get to. We're like incrementing our way there. We're almost there. We're nearly there. So we just need to make it work about right. So let's see. Okay, 26. How do we do that? I guess we could do 13 by 2. Can we do that? Is that something that will be nice? Will it play nice if I do that, or is it going to have a problem? 2 by 13. All right. So right. So it's got to be. We need a 5 by 6, maybe. Is that going to work? 5 by 6. We'll find out here. Invalid input size for 26. We'll get this. We'll get it. We'll figure it out. Gonna leave to shower, bro. Live was really chill. Definitely come back next live. Thank you. Key Nevo. Sounds great. Take care. Much love. Sounds good. Enjoy your day. Are you on Linux? Just curious. We are running on Darwin. Uname-A. Or can we just do Uname? Yeah, see, we are on Darwin. Here, I don't know if you can see that on the screen. It says Darwin right here. Darwin. See Darwin. Yeah. Right here. See, Darwin, which is Unix-based system, right? Basically a Mac. We're running on a Mac is what that is. That's what that means. Thank you for the likes. Yeah, thank you for the heart. I saw a floaty heart icon there. Okay, so invalid for input size of 26. Right, I got it. What if we did 28? So we can't though. 14. It's got to be at least 5 by 5. If we do 25, let's see here. There we go. So that will cause another problem, right? Because it's not the right shape. So from docs seams, let me know, Savon. Let me know. We're trying. This is like the easy part. We're like stuck on the easy part, which is disappointing, to say the least. It's disappointing. We need to get the right shape. The live subtitles are really cool, aren't they? They're neat. Yeah. So we've got the CNN. So here, check it out real quick. So I'm the CTO of PubNub, and these subtitles are powered through my technology. They are the transcoder that encodes voice to text is captured through a standard neural network, and then the data on the output side, the tokens, are transmitted over my network on my technology, and you can see how fast it is. It's transmitted in real time, and so you get this overlay here for open captions, these subtitles. It's really neat. And it's open source. If you want it, it's open source. It's on our Discord channel if you're interested. If you are interested, the CNN works with pixels. It can work with any floating point numbers, right? And we've got a grayscale picture at this point. We have a grayscale picture. Or can it work with any signal tokenized numerically? Numerically, yes, it can work with any numerals. I know it can. I know it can work with numbers. I know it can. I've done it before. I just realized you're doing something kind of weird, which is first encoding as a float, then passing that float into the CNN. That might work, but not what I meant. Oh, really? Do we not have to do that? Well, I mean, it should work anyway, but you're saying that we don't have to do that? I remember running through the MNIST training set, and you still have to normalize the data. right? So my encoder is really just a normalizer. This is really just normalizing, right? So it takes the XY coordinates and it converts them to the shape of my normalization, which is the screen size, the size of the screen. So that should be fine. That part is fine, I think. The part that I'm struggling with right now is getting the right shape for the input on the CNN. It's nice. Maybe you can adjust so when you have a voice pause, like saying, last word disappears until you talk again. We could do that. We can do that. We can absolutely program that because it's open source. I know exactly where to do that. That is a good idea. Let me read that again so I can remember it. You can adjust it so when you have voice pauses, like saying, last word disappears until you talk again. Ooh. So then once we detect the or that sort of thing, we can just eliminate those words and make the screen disappear. Yep, we can absolutely do that. It's actually pretty straightforward. Like the idea was always having a 2D canvas, which has the XY spots have 1. So it should always be easy just because we set... it should always be easy because just set the encoder. Like MNIST is specifically the other way of doing things. Right, because I thought it flattened the array. I thought it flattened the array into a 1D, like 768 or 786, right? It creates all those pixels, and then it converts it to grayscale, I think. And then it converts those into normal. It normalizes it between 0 and 1, right? The pixel value, the color, the grayscale value. And then it flattens the 2D into a 1D. I remember seeing that in the MNIST. Stephen, you could briefly explain the approach using the CNN for the click prediction. Yeah, okay, so it's pretty straightforward. So what we have here where is it? We've got our clicks. We've got a whole bunch of clicks, which are XY coordinates, right? We reshape and normalize it, so it turns that XY coordinate, which is like 100 by 100, down to 0.1, 0.1. And then we convert it into a one-dimensional array, and it looks like this. So you can see what what that looks like here. So you can see XY. That's one XY. Here's another XY. Here's another XY, and then another XY. Right? So it goes like that, and then it just repeats, and so it's XY, XY, XY. We switched to CNNs. Yeah, Kevin McAllister. Yeah, we're doing CNNs. We're struggling. I'm trying to get the input to work properly. I'm saying do CNN. Yes. So MNIST is an MLP. Oh, it is. Got it. Okay. So then we're doing it weird then. So what if we didn't do any encoding? Okay. Okay, Neva, we'll try it. We'll try this. Some people saying AI at Google is funny. Let's check it out. All right, Neva, we'll try it.
Generative AI. Third, AI. Deploying AI. Finally, rigorously tested AI with AI.
Yeah. Large language models with AI.
Power of AI, generative AI, AI platform, AI.
Tailwind, AI first AI model.
The moon landing is AI generated.
Generative AI, powered by generative AI.
With AI at the center. Leading edge AI research with Google's AI in the cloud. Personal AI.
Building AI. Sorry.
AI. I'm thinking they used the word AI. Is that what that is? They're thinking of AI. What are convolutional neural networks? They are JDC. They're essentially, you've got a picture here on the screen. So see, each of these squares are like are pixels of the image, right? So you get a picture of a cat, picture of a dog, and these are all the pixels right here. And a CNN will sample each pixel and collapse it like sort of an average or some other math operation. And then it scans. It scans over each of these pixels. It grabs the first 4 by 4 or whatever your stride or your padding is. Whatever your padding is, you might have a different padding. And then whatever your step is, it'll step to the next, and then it'll step here, and then step here. And then your output is 4 values. So 1, 2, 3, 4, like this. Like this. Your output will look like this. And so this is that's one pass on one filter through the conv. Will give you these 4 output here, like that. So that's what that does. So it samples over your image, and then it creates new values. And what it is, once you do that multiple layers on a conv2D or which is a 2x2 or a standard picture, it will start be able to detect shapes. It'll be able to start understanding shapes like circles or patterns or triangles, and then maybe like a nose that's kind of like a triangle shape, and then it'll start being able to then you put another conv layer on there, it'll start being able to recognize what a face is, like a human face, because you've got multiple circles and multiple shapes together. And so that's what it is. That's kind of what it is. Oh, you sent the encoder? Oh, in Discord? Thank you. Neva, thank you. Excellent. Eldar, how's it going? Eldar, hello, bro. Welcome on in. Good to have you here. All right, let's take, so here we go. Encode point XY size X, size Y. Floor. Oh, this is the resolution. Okay, yep. Output equals. How does that work? Oh, let's copy paste this. Okay. Encode 1 point. So, okay. Okay, encode point. So this will be the screen size. So you got the screen size, XY, right? I guess this width and height of the screen is my guess. Then you've got the position, and then you're creating an integer value that's very big. Wait, what is size XY? Actually, because you don't need, right? You don't need that, right? Wait, how does that X comma Y equals 1? Oh, so it's a position. Oh, I see. Okay. So you're making a giant image here. So you've made a large image, and then you're updating the points on the image. That is neat. That is different than what I'm doing, and I like it. Okay. We've got multiple points, though. So, okay, Neva. Okay. We'll do this. This is great. Okay. I like this approach a lot better. All right. I think this will be great. And then we don't have to do any reshaping or other things that we're trying to get things to go in places that don't need to be where they are. Okay. So let's hide that. No more of that. And then we'll do features. Instead of this, we'll do features. Will be a encode. We'll call encode CNN. Let's call it encode CNN. Okay. Let's see. Old, and then we'll call this encode CNN. Here we go. Okay. All right, Neva. I see what you're doing. All right, so this will be instead. I want these to be chords. So we'll do chords, like coordinates. So there'll be multiple points, and then we'll create the screen. X, Y, floor. Oh, this gets at the position. Got it. Okay, so for chord in chords. So output will be this. This will be width height. I'm just gonna say width. Height, H-E-I-G-H-E. Width, height. Okay. Thank you, Neva. This is great. Can be smaller than the screen if you want, like a fourth of it. Okay, so it could even be a smaller picture. We could do even a smaller picture. So let me add that as a to-do. to do can be smaller input. Because the input is big. It's pretty big. It's quite big. Can you unpin you? Yeah, I will. I'll unpin you. Unpin. There you go. I mean, it could work, but it seems there must be a better architecture. Yep. And Neva has just taken us to the next level. Has just taken it to the next level. The key connectivity can make it work around. We could have made it work. Like I think we could have made something work there. Now it's basically, we're doing a one hot. We're doing a one hot. Or is it a two hot at this point, right? It's a two hot. You can do the same 2D image, but you would, some exponential back off or something to the most recent clicks is highlighted. All right, good to know, good to know. I don't know Python, but if you put a floor in a line instead of a floor, what? Let's see here. For width HEI. Can we just we don't actually need to do this. I don't think we need to do this step here because our chords. See, x equals chord 0. Y equals chord 1. I don't think we need that. We could do that. That still can happen. And that will convert it to 1, and we return output. Okay. Looks good to me. Looks good to me. Okay. I don't know Python, but you put floor in a line instead of floor. Oh, no worries, no worries. I think I completely see the picture. I see what you've drawn. So we're going to have a giant, right? So a giant full screen array, two-dimensional array of X, Y coordinates that are all zeros. And then we capture the coordinate of our click, and then we update that as a position as a value of 1 on the screen. And that will be the input for our convolutional neural network. That will work perfect. So all we have to do is pass in the chords, and now we don't need 26 clicks. We can do this perfectly fine with just 8 or even 6. We can do it even with 6. And that means that this will work fine here. I think we're good now. Yeah, we're creating probability map. Nice. Probability map. This is really helpful. I'm learning a lot. We're learning a lot here. Okay. So is that it? Did we do it? Are we alive now? Let's see. Where is the... Do we want to print this here? I do. I want to print this. So let's print this. We'll do features. Features. Let's just do it like this. I like it. There we go. And then we'll do features. Post encoding. Okay. Great. Okay. We should be good now. Let's try it. Let's see. I feel like I missed something. Missing one argument. Okay, right. Okay, I am missing something. Here. Let's see here. I need to change this. How do you do a step 2? Okay. In Python, how do you do a step? Or I suppose we could throw an if in there with the modulus. Hey, Steven, long time. Just wanted to say that I got a data science internship starting from July. Congratulations. Hey, that's great. That's great news. Good job. Great job. Good job. Nermit, you did great. That's really hard to do. You made it. You made it. You got your foot in the door. Keep on going. Do the best you can do. Do the best you can do. Make it happen. That is amazing. Okay, so I've got my coordinates, x, y, la, la, la. I want to step by 2. Can we do that? Let's see. Python range step 2. Let's see if we can do this. Is it like comma 2 or something? Okay, 0, comma 10, comma 2. Okay. So let's try this. Let's try it out. Python. Print range 0, comma 10, comma 2. That should be 0, 2, 4, 6, 8 or something, right? Okay. For a and range, print a. Thanks. 0, 4, 2, 4, 8. All right, excellent, excellent. Okay. 2. Okay. Perfect. That should do it. That should do it right there. I think. Let me double check. 10. Yes, 9. 0, 9. Perfect. Okay. That should do it. You started trying to learn Python yesterday. It's hard. It'll be hard just for a little bit, and then it gets easier every day. Just a little bit. Just keep going. A little bit easier every day. Just a little bit easier. Okay. I think this is what I want. We might want to reduce the width and height a smidge, because this is going to be a very large input. Like, it's massive, and it might completely freeze our computer. So we might want to reduce the input features. Oops. All right. Python main. Okay. 2 required positional arguments, width and height. Oh, right. Where's that at here? Game dot this. Okay. That does look hard. Wait, what is shortcut to X range? Oh, list range saves me the for loop. Oh, nice. Iterations for context. That's actually really useful. Thank you. What makes you so awesome? Karmu? I don't know. Thank you for saying that. I assume that you're giving me a compliment. I assume it sounds like a really nice compliment, like a really good one. Effort, persistence, keep going, don't stop, don't give up, keep trying, failing. Here's actually the key. I've got the answer for you. Anticipate failure and count it as something that's actually really valuable. Failure is your learning. If you learn, you figure it out and you remember. And that failure is critical. If you don't fail, you can't remember and you can't grow. And expect to fail. And what I do, here's what I like to do. It's my favorite thing in the world. I like to intentionally find places that will cause failure. I like to push and pull and stretch and find like the limitations and the barriers of failure and the barrier of success. And the more you fail and the more you will succeed as well. And you'll find like the failure over here and the success over here, and you'll find the line in the middle, and you'll learn how close you can get to that line. Therein lies success. I think that's what lies success, finding the barrier. Today you learned what modules are. Nice, that's a good progress. You want to propagate stuff out. The issue with large size loss is the freezing. It's 9 flops per pixel should be fine. More so it can't properly propagate. Okay, got it. Well, if we need to shrink it, we'll make progress. We'll make progress on it. Features game. Chords. Oh, we need the chords. Yeah. Okay, that's the features. All right, chords are the features. Game, and then width and height. Where's that at? Okay, here we go. Okay. So now that should be good. Okay, we've converted it. We've converted it. That should be much better. Wait, oh, you're cute. Do you date other engineers? Propagate. I see what you did there. I see what you did there. Nice. Hey, the Jam, how's it going? Finally caught you. I know Python when I see it. Yep, you got it. What fun thing are we doing today? So we're taking our click predictor, which kind of predicted the click. It didn't predict very well. We are making it actually predict the clicks now. Neva, who is in chat, is helping us a lot. We are converting our MLP into a convolutional neural network. And what we did was we're taking all of our clicks and we're putting them on the screen. So you can see there's like a picture here. So if we have a click, then we'll like draw a one here. Like, so all these are 0 by default. So 0, 0, 0, right? So that's what Neva's given us. We've got 0, 0, a whole bunch of zeros all over the place. And here as well. However, this one is going to be a 1. Like say we click here, that'll be a 1. And so that's what the picture looks like. Let's see, close that. Click. 0. And we are going to be a convolutional network. That's what we're doing. That's what's happening. A click predictor sounds dirty. I know it kind of does, right? A little bit. Sorry for not being super clear about when the idea might have needed to give you the code before streaming. It's all good. I really liked learning. So I like failure. That's one of my favorite things. I like to run up against what doesn't work. It teaches you more than anything else in the world. I really like to do it. It's my favorite. So Neva, we're off. We're doing good. Whoa. Hey, we got a super chat there. Thank you. I paved my own road. You paved your own road. Thank you. That's so... Thank you for that. What are you doing there? I'm just sending $2 over there. That's great. Thank you. I appreciate it. Also, you're gridding the pixels out. Yeah, the GM. Yeah, Neva has helped us out a lot. That's what we're doing. So we're building a fake image for the CNN to work. Yep, you got it. We're building a fake image. That's what it is. What is a click predictor for? What is the game? So we can use this for checking and defensive AI defense. So we're building an AI to predict where the next click is going to be, and we can use that to predict whether it's a person or if it's an AI. We can find out if the click is a real human click or if it's a fake click, right? We can do a lot of things, and you can do a whole bunch more with this. Is a whole bunch more. That's just one of the examples. That's one of them. Hi, after a long time, Kingmaker. Good to see ya. I love food. That's cool when you cool though. It can predict when you click. It can predict anytime. You look handsome. Whoa, Pablo, thank you. That's great. That's a really compliment. That's a really great compliment. I appreciate it. And again, I paved my own road. Thank you for the $2. Thank you, you guys. Thank you for being here. This is a lot of fun. I'm enjoying this. We're gonna get it to work. Thank you for the heart icon. Thank you for clicking like on the stream, you guys. It's not really fake. It's an image showing the clicks. Yeah, technically, yeah. It's a real image. It's a real image. It's just showing the clicks. It's not a fake image. I mean, it's a synthetic image, we can say. That's what Savan is trying to say. It's synthetically generated image. So it's synthetic. Yay, anti-AI is the best use of AI, right? Isn't that great? Yeah, we're doing anti-AI. It's essentially anti-AI. You can use that for your own CAPTCHAs. That's really cool. You could, yeah. It's true. That's how CAPTCHAs work. They mainly track how your mouse moves. I think so. Exactly. All right, so... Now we've done this, I do believe everything should be in the right spot. So we've got our coordinates on the input. We got the game. We've got self. So it's going to be a very big picture. Game, encoder CNN. The name game is not defined. Did you mean self game? Yes, I did. I certainly did. I'm pretty sure. Let's find out. Does it have access to game? Yes, it does. Okay, great. Okay. All right. Is it going to work now? Is it going to finally work? Torch module has no attribute zeros. Okay. We can figure that out. Don't worry. That was just some pseudocode. We can fix that. Zeros. Like that. Can we do that? Is that going to work? No, it doesn't. All right. We'll figure it out. Do you really enjoy watching the stream? Nice. Also, someone codes my idea. I'm too lazy to do it. Hey, I'm happy to do it. I'm happy to be your coder. We need to figure out what the actual zeros function is here. That kind of gave you an idea to remake it, but it's a CAPTCHA in HTML. Now we're thinking. Yeah, you could really do this. You could do this. Web app. You can make a web app. Stephen, might you add a debug learning step rendering the synthetic image for human in the loop? Ah, yeah. Savan, all right, we could do that. We absolutely could do that. We could render that on the screen. Where should we remember it? All right, so let me add that as a to-do. To-do, render the output. All right, here we go. All right. We all know it. It's going to happen. It is going to happen. Pablo, do you work at a company or yes? Okay. So Pablo, I've got your answer. I am CTO at PubNub. We raised 134 million in a series. We have at Series E. We have over 1 billion connected devices and 68 patent claims that have been granted. We've got more patents out there, and we're still working on right now. Those are the granted patents. So we've actually got those patent claims. I've been doing this for 25 years. I've been 25 years in tech. In paid tech, I'm talking about like when I started getting paid. Obviously, I've been doing technology before that. Appreciate it. Thanks. Yeah, I think it'll be great to visualize that. And so Pablo, PubNub is a communication platform. We power a large amount of the internet. You've got over 1 billion connected devices. And are you familiar with like food delivery, on-demand delivery type, and sporting collaboration apps, multi-user experience apps, multiplayer games? We do it all. We do all that stuff. If you've got a smart TV, if you've got an Internet of Things device at home, like a smart lock or a smart bulb or a security system, like that's connected to us. And we do the signaling. If you've ever used chat on the app, like you're using chat right now, that's connectivity technology. Oh, wow, that's really cool, isn't it? I think it's really neat. And so this channel is about, what we talk about on this channel is anything that you want to know over my years. I'm happy to tell you what worked for me, how we built our network, how we built our infrastructure, how PubNub works, how to build large-scale systems. Also, we're mostly focused on building AI. And so today, we're building a Python application that uses Pytorch, which is a prominent AI library built by Facebook Meta. It is the most widely used AI library, and we are using it right now to create a click predictor and an AI that can check where the next click is going to be. That's what we're doing today. That's the plan for today. Okay, so what? And then so we need zeros. Okay, Python import torch dot zero zeros. Okay, 10 comma 10. Excellent. Okay, so we got to spell zeros properly. Wait, is that how you? Is that is how you? Isn't zero spelled with an E though? Is that spelling? Are we spelling properly? How do we spell properly? Zeros versus zeros. Which one's correct? Both zeros are correct spelling, plurals form of zero. Interesting. So in PyTorch, they just don't use E. Yes, zero. Yeah. Isn't it neat? Okay, so they're the same. It's just PyTorch. Okay. So Z-E-R-O. Where's that at? Here we go. There we go. Okay. That will fix that. All right. Python main. There we go. Let's see if we get it work. Okay. Chords is not defined. We can fix that. Yeah, it is. It's right there. Yeah. Oh, position. All right. So. Chords. Okay. There we go. Okay. If this works, it'll be so scary using anything to influence the clicks, or it's just learning a pattern out of a bunch of random clicks. It's learning a pattern out of a bunch of random clicks right now, and it should be able to get pretty good because I gave it like a fairly consistent pattern. So we'll find out if it works. I'm pretty sure. I'm pretty sure. AI that prevents AI. We're in the future. That's the only way to battle AI is with other AI. Okay. Expected 3D unbatched or 4D batched input conv2D, but got an input size of 9. Okay, so we could fix that. No worries. We will do 1. Let's see here. 1. Okay, that should do it. Okay. Index out of 0. Ha! There we go. Yeah, here we go. Okay. Matte shapes cannot be multiplied. A very large number. Okay, 16 by super big. And 256 by 32. Okay. Okay. I think you forgot to batch them. Is it batched? You might be right. You might be right. Let's see here. So, let me see. Where's our forward at? Forward. Also, did we encode it? Yeah, we encoded the feature. Or do we need to encode them? I think we're good. I don't think we're essentially encoding. This is essentially we're doing that, so we don't need to worry about that. And then where's our forward at? Here it is. Model features. Okay. So yeah, it is batch. You're right, Neva. So that is what it is. We figured it out. You're absolutely right. It was the batch. Hello, bro. Dudes Films. How's it going, Dude Films? I want to do something big this year. Can you motivate me? Sure. What are you interested in? Do you like AI? Do you want to build a mobile app? Like, what are you into? Oh, I got the conv. You need an average of some sort. Oh, got it. Okay. You need it to reduce the 2D to a thing that's not 2D. Okay. So, we pooled it, and we did another conv 2D, and then we flattened it. Right? So that the flatten shouldn't that do the trick right there? I think maybe the flatten should do the trick. I want to get the job. Oh, Dude Films. Oh, the job. Okay. That sounds like a good start. That sounds like a great start. Which job, though? Which job are you thinking about? Trevor Smith, thank you for the jewels. Whoa, Trevor Smith is sending a whole bunch of jewels. Whoa, thank you. What are you doing over there, Trevor Smith? What are you doing? Thank you for those. Thank you for the jewels. Thank you for the jewels, you guys. Trevor Smith, you guys. Okay, so tech. Oh, do tech. All right. Well, that's pretty broad. That's pretty good. That's a pretty broad. It's fairly broad. There's a lot in tech, right? So you got big data. You're looking for statistics. Or you came across. You wanted to say, keep it up. Thank you, Trevor Smith. Trevor Smith. Thank you so much. That's a great way to say complimenting me. To say, hey, you're doing a good job. Keep on going. Thank you. We'll keep on going. We will. Thank you for the jewels. Appreciate it. Oh, thank you. If you need someone to work on a project with, I'm looking for something to do too. Nice, Neva. Okay, dev, software engineering, got it. Quant or like security or what? Exactly, because you could do a lot of things. There's a lot of things. What would you do if someone sent $500? Just curious. I would say thank you. I mean, hey, thank you for sending the $500. That's unnecessary. You don't gotta. That's very, very courteous. I would say I would be unable to reciprocate in such a way. Just finished my Haskell intern, your interpreter. In a way, I'm kind of happy with it. Nice, Neva. That's great. That is that sounds challenging. That actually sounds like a really challenging task. Can you show to do the contribution in GitHub? Oh, can you show how to do the contribution in GitHub? What do you mean? I mean, you could post your repository there. You can show your profile. Like, there's a lot of things that you can do there. So yeah, here's our GitHub repository, or here's our GitHub, right? Here's our GitHub, and we have all of our repositories, and we've been doing lots of different things. Click prediction is what we're currently working on right now. And here is the code, all on GitHub, available for free. And it's not very much code. It's just not. It's not. It'll be a little bit more, though, here in a little bit. Steve, you need merch. Then for sub donations, you could gift some rate. Oh, that's right. That's a good idea. We could gift. Is there a way to gift? How do you do that? I know you can do that. Add, put, remove, report, pin, go to channel. I know there's a way to do it. I've never done that before. It'll be something that we do in the future. Rare PubNub merch or so. Yeah, we could do that. We could do some very rare PubNub merch. You got it. Interpret written in Haskell, not for Haskell. Oh, got it. Okay. Got it. All right. That makes more sense. Got it. Okay. Got it. I think you can gift memberships. Torva, I want to try that. I want to try that. If you can tell me how to do, wait, there's a money button? Membership gifting. Okay. I'm going to try it. We're going to try it right now. We're going to try it. Here, let's check this out. Here we go. All right, let's go, you guys. Let's go. Let's see if we can do this. Let me pull this over here so we can see. Okay. Send 5 now. Send gift memberships free of charge. Really? I can do it free of charge? You have 10 gift memberships left to send this month. Whoa, I didn't know I could do that. Hey, check that out, Torva. All right, guess who's getting a membership, Torva? All right, send 5 now. Wait, can I send? All right, well, 5 of them just went out. There you go. I don't know who got them. I have no idea who got them. Received a gift membership. Hey, Torva, you got it. Very nice. Check that out, you guys. You get some gift memberships. You've become members. I didn't know you could do that. Hey, Torva, thank you. And guess who got it? You won the lottery. I know. You want a membership too, Carmu? I would like to give it to you. I don't know how. Let's see here. Let me see here. Let's see how we can do that. Let's see. Gift memberships. It only allows me. It doesn't let me pick. How do I pick specifics? Hey, Dude Films. How's it going? All right. You want a membership, Carmu? How do I give it to you? That's the thing. It won't. Let me see here. Community moderation and React pop out. Well, I'll have to keep looking. If you guys figure it out, let me know. Let me know if you figure it. Can you hack Torva? Hi, Steve12. How's it going? Good to see you. Of course, you always got to come in with one of those questions. Good to have you here. Hey, bro, I didn't get one. Dude Films, if you tell me how, Carmu, I want to give them to you. So there is an option for me to click, and it's going to be random. It'll be random. So it lets me gift memberships, but it won't let me choose who to gift it to. Right now, it won't let me choose who. So here's what I'll do. I'll send 5 more. And we'll see if you get one. All right? We'll see if you get one. It's a luck of the draw. All right, let's see if it worked. Who got it? All right. See, Abdullah. We got Theo is light. And then John. And then Mr. Nobody. Oh, your subtitles just said caramel. Did it really? Hey, I paved my own road. Thank you for the jewels. I see you got some jewels sitting over there. Thank you. I see him. You didn't get it. Oh, no. Let me see if there's a way to gift more. Can I gift more? Oh, okay. Let me see here. I'm going to try. 1 second. So I don't see how to select you. Right on, man. All right. So let's see here. Are you memberships on YouTube or Twitch? They're on YouTube. We're doing YouTube. YouTube is the go-to platform, you guys. It's all about YouTube. All good, bro. Hey, Carmo, if we could figure out how to do that, let me know. Gab flagged my account for no reason. Oh, no, that's terrible. You don't want a flagged account. YouTube distributes gift members to viewers based on how much they interact with your channel. For example, loyal viewers who are always watching and interacting with your content are more likely. Torva. Okay, there we go. So that's the way to do it. So I can only, it's a random chance. Well, it's not that random. It's based on how active you are in the channel. So that's why, Torva, you received the gift memberships. There we go. All right, so Carmu, all you have to do is chat a whole bunch. just type a whole bunch of chat, and then I can send it over to you. I can send it over to you. Hey, I paid my own road, just became a member. All right. Thank you for joining. You've joined the right channel. So in case those who are here, who didn't know, I'm CTO at PubNub. We are a communications platform for built-in app communication. We raised 134 million. We are at Series E. We have over 1 billion devices connected on our network and 68 patent claims that have already been granted. They've already been granted, and I've been in tech for 25 years. Actually, longer than that, because I'm only counting where I've been making money. Only where I've been making money. So I'm happy to tell you through my experience what worked for me over the years. My technology here at PubNub.com, you can see we are the leading platform right now, the leading in the world for real-time interactivity on apps. So if you've used ordered food, if you've experienced multi-user experiences, are you hiring? Yes, we are. We are hiring. We have a open role. So I do believe there's a careers button around here somewhere. Careers, you click that and you go over here and you see we've got a couple open roles. There's a senior software engineer that is currently open. So right here, it's remote. A member, wow, cool. Yeah, I know, isn't it neat? I think this is really great. I just became a member. Nice. And paid my own road. Thank you for joining. Let's see here. Okay. All right. What do you mean by real-time interactivity? It's like, have you heard of WebSockets? Have you heard of service and events? Have you heard of like chat or multiplayer games? Those are all signals that go across between computers. And we are a globally distributed infrastructure running on AWS. We run in all the Amazon's data centers. You are a user who connects up to the closest data center with your phone, and you're able to communicate at light speed, of course, the speed of electrons. What about freshers? Currently only senior. We're only looking for senior at the moment. With Stream, like WhatsApp. Exactly like WhatsApp. You've got it. You got it like WhatsApp. Exactly like WhatsApp. It's great to have you guys here. All right. So open roles on PubNub Careers have a link in our Discord. Yes, Torva, thank you. Exactly like that. Oh, you're in Poland? We're global. We're everywhere. We're in India, London, I think Mumbai, right? Mumbai, and Poland, right? Katowice. We're in East Coast U.S., West Coast U.S., and several other places around the world. Very nice, isn't it? You're not hiring in U.S. Yes, in Canada, in U.S. as well. Yes. Yes. We are as well. And we'll hire the right person. So it doesn't necessarily have to be Poland, obviously, because it's remote, right? It says remote right here. Remote. Remote being the key word. Remote. Remote. This is a remote first role. Right, there you go. Are you the boss? Well, I am. I started the company. I started it. And my co-founder, Todd, is the boss. He's the CEO. He is the boss. My co-founder, Todd. Yep. Based. Are you based? Kyle. I remember 13 years back, there were quite some competitors for real-time messaging, and now there's Firebase and others from Apple. Use Apple, but PubNub's ease of use and performance is something else. Yep, there you go. Yep, we're easy to use. Easy to integrate into your app, and you can use it for multiplayer games, for on-demand delivery, for chat, for signaling, for real-time charts and graphs, a whole bunch of things. When will you open for freshers? We'll let you know. We'll let you know when we have some. We'll let you know. Hiring software engineer from Poland is based. You look on PubNub Careers, all open roles are published there. Thank you, Torva. Thank you. Yes, exactly. All right. So, we'll give it a little bit more time here, but we do got to get going. We are running low on time. Actually, we're past the usual amount of time. So like we've been streaming for almost 3 hours. Usually we only stream for 1 hour, but today was special. Getting the start to the week. What's your current role in the company? I am CTO at PubNub, and I started the company many years ago, and we've come really far. We started with multiplayer gaming and on-demand delivery, taxi dispatch, those such of things. It's just too fun, isn't it? Best developers docs demos I've ever had the pleasure to use. That's great feedback, Savon. Thank you. Thank you. That's great. Bro, what do you think about remote market for overseas programmers? It's great. It's fantastic. We take advantage of that as well. We work with everyone. We're a remote first company. So we hire everyone under all roles, get to be hired anywhere in the world. Let's see here. So where are we at now with this? Okay, got it. So we just need to manipulate this here. We just have to manipulate the shape size here. So we'll figure that out. Okay. Oh, the resolution of the screen. Okay. We can figure this out. Any suggestions for the programmer? Okay, so at PubNub, we use Rust, the Rust programming language. We use JavaScript and React for our admin dashboard. We use Python as well. We use C. We use Go. And some JVM languages. And so there's a lot of options available, and different along lines of what languages we use and what we're expecting. So Python, JavaScript, Rust, C, JVM languages, and Golang. You're so confused? Oh, Rust in production is kind of crazy, isn't it, Neva? We use Rust in production at mega scale. Like, we've got over 1 billion devices. So we might be among the largest on the world right now that has deployments of Rust in production. We might be among the largest scale in the world for Rust deployments. That's us. That's who we are. The largest in the world. And you didn't even know about us this whole time. Is neat. Rust, Python, need for C#, right? Oh, C# is there. I like C#. We support SDKs in every language. So C#, PHP, Ruby, Erlang, C. We've got PIC32, ESP32. We've got it all. We've got Arduino, C++, Unity and C#. We've got Unreal, C++. Everything. We've got it all. Okay, I see Rust, Go, JVM, like you can pay for extra cost with GC implementation and atomics. What's Golang used for? A few of our APIs are written in Golang. So we've got like 70 plus APIs. I need to look at it again, but we've got a lot of APIs, and they all have different backends. Mostly it's C or Rust, some Python, some Golang, and some JVM. Go, yeah, Go. I've had a fiddling around with Go and a packet sniff. Nice. On my self-hosted Minecraft server for kids. It's interesting language and wasn't really nearly as bad as I thought starting learning. It's pretty great. It's kind of close to Python in its syntax. It does have, colons. It uses a lot of colons, like colon equals. It likes the colon equals. He's the API guy. You got it. Well, when there's a junior role open and I'm done with school, I might apply. Sounds great. That sounds great. Also, I am planning on some future adventures. So some more adventures in the future, and I would like to do that as well. So there's some opportunities maybe in the future as well. That is the plan. Okay. So I know what this issue is. It's really simple. It's a really simple issue. This resolution right here, I do believe is 27 by 84. I do believe is the product of the dot product here of our input game size. So width. Where that at? I think 900. It's 900 by 500. So if we calculate that, so 900 times 500 equals 45. That's 500,000. So that's not quite what I was thinking. All right. Well, we'll figure this out. But we do gotta go in. Oh, hey, how's it going, Milik? How's it going, Milik? Hey, Steven, have a technical coding interview coming up. Nice, that's great to hear. From a big firm, wanted to see if you had any advice. I feel kind of stuck on how to prep. So the big part is it's personality matrices at this point. They want to see if you're a good team fit, if you're going to be working with them. There's obviously a technical interview, mostly just to say, hey, do you know enough in order for this to achieve what you need to achieve in this role without having too much overhead on your initial learning when you get introduced into the company. That part is easy. The hard part is being a personality fit for the culture of the company. That's the most important part. You need to make sure that you can feel like you can get along with the team that you're applying for and that you have a good like camaraderie. That's huge. That's a big part of it. But doesn't the effect of latency, I would expect all endpoints to use Rust to keep consistent latency. You are right. So our main message bus is written in C and Rust. And we are actively converting it over to 100% Rust. So there's still a large chunk of it written in C, and it's currently deployed in the infrastructure today. So the main message bus is all C and Rust. When it gets to ancillary, secondary, and subsidiary APIs, subordinate APIs, they are written in other languages like Go and JVM, Python, and Rust as well. So it's actually fine. Hey, Fractal Cow, how's it going? Steven, I'm struggling to get a job in Gen AI. You don't know, the market is weird right now. They don't see how much they can benefit from me. Oh no, that's terrible. You got to keep trying. Don't give up. Do not give up. Keep going. Keep on going. That's the idea. You got to keep on going. Okay. It's great to have everyone here. I think we had fun today. But I do got to get going. I know what the problem is here. We can easily fix this. It is based on our input size, and I think we can adjust that. It's based here. Let me see here. Mat1 and Mat2 shapes cannot be multiplied. 256 by 32. Okay. 256 by 32. Where's that at? Right here? Ah, okay. So it's actually right here. So what is the output size of this? Let's try it. Let's try it. I do got to get going. I have real paid users now. Oh, nice. You got real paid users. You're on the right track. You're making it happen. You're making it happen, Kyle. That's great to hear. Nubby Pubby, how's it going, VRO? What got? How's it going, VRO? What got? Good to have you here. A pool divides the X and Y by 2. Is that all that does? Okay. A pool divides X and Y by 2. Got it. So fourth of the previous size. Okay. Got it. So it's reducing. So this is a reduction. This is a reduction of the input. Okay. So very big input, and then we reduce it by half, and reduce it by half again. And then this is where I'm struggling now. So I need to see what that needs to be right there. Okay, so 3552 by 112, 256. So that 256 needs to be different. Let's see. What if we do flat now? Let's see, flat. You send in Discord? Sounds good to me. 16. Okay, so regular 16? Like that? Can we do that? Oh no, because it's transposed. No. It's by half. It's by 1/4. So you're 1/16 the size. Oh, the fourth of the previous size. Got it. Got it. Sounds good. Talking to Neva. I do got to get going. I would like to be able to at least get this to run once through here. So 16 by very big. Can we do, let's see, 4. Let's do more. Make it smaller. Yeah, okay. So that did make it smaller. So I suppose we could go 1650. I mean, that's massive. Wait, 16 by 16 and 8 by... Oh, okay. Yep. There we go. Now we did it. We did it. Oh, I thought we did it. The size of tensor A32 must match the size of a tensor B. Oh, output minus labels. Oh, got it. Okay. That should work. Why is it not giving me a 2? What is the input resolution? Very big. Let's see, it's very big. Very, very big. All right, so 900. 900 by 500. So, kind of big. It's kind of big. Let's see here. But the output size should be 2, and this is where we're at right now. And this should be 2. So why it no worky? Why it no worky? The size of tensor 32. Where is post feature encoding? Yeah, it'll be a very big number. What is the output? Output minus? Okay, let's print this. Print output. Okay. Show me the code again. I want to run through the size. Are you talking about... Here, I'll commit it to Git. I'll commit it to Git so you can see all of it right away. Git status, Git, add main and clicks. Partway CNN. There we go. Push. Okay. Here it is, and I'll just repaste it so it's really easy here on Discord under the free resources. I'll just repaste it. Let's see. I'll do it right here. There we go. That should take you straight to the code. So you were trying to recall how matrix transpose works from a linear algebra. Yeah, it's really actually pretty. It's really simple, right? You're changing the xy into a yx. Yx, right? Very, very easy. Size of tensor of 16 must match size of 2. We printed it out. Why is it doing this? That's weird. Sneaking mission music, is it? It's called Art Drop of a Hat from the Gray Room and Density and Time. Let's see here. Why the output tensor like that when I have the output tensor? It's so weird. It's so weird. Let me do another one. 2, 2, 2. Extra 2. Yeah, it says it's 32. Why? Also, it's negative. There's a whole bunch of negative numbers. That's not good. The output is totally broken. Simple, but it's such a cardinal operation for matrices, isn't it? I know it's simple, but it is. It's a linear function. So it is. There's some expense. Let's see here. Although when you're doing GPU coding, it's actually kind of nice because your transpose, you literally just you flip your accessing xy to yx, and that's the transposition. It's really simple. When you're doing GPU kernel programming, it's really, really simple. Why is it 32? So weird. This is messed up. This is messed up right here. This should be 30. It says 32. But when I should know. Is that because of this? What if we did 16 here? Still says 32. Okay. All right. Well, what do we want to do next? You didn't know that? It explains a lot for GPU use. It's great because you're actually just changing the way you're accessing the memory, because you've already put the memory in really fast access memory, and it was like ultra fast memory access, whatever that is, and then all you're doing is referencing the memory and the data based on which core you're in. And so you've got your thread coordinate to say what core you're in, and then you've got your other coordinates based on the current pixel position, and it lets you easily and quickly simultaneously iterate over a giant image or an image or a segment of an image, depending on how big it is. And then you just invert your XY to YX. It's really simple. And that's how you do transposition in GPU kernel coding. But for the life of me, I'm trying to get this little simple output thing. I mean, we made a lot of progress here. Don't get me wrong. We've made a lot of progress. Steven, your max pooling is something weird. We'll try making the second pool just 2x2. The second one? Okay. Done. Okay. 6,600. Very, very big. 6600. Okay. All right. So that adjustment's good. All right. So we made an adjustment there, Neva. We're on a good track here. Now we need to figure out how to get our output to work the way it should work, and it's not, which is very odd. It's very odd. Why is that no worky? I'm actually kind of curious. Can you print the actual shape of the tensor in the point of breaking? Well, it fully works, so it feed forwards. The whole feed forward is successful. The problem is the backpropagation and the output. So I'll just print the model and the size of the output. All right, so output. Where's it at here? Here we go. All right, so print dot size or dot shape, right? The shape. Okay. Shape. Okay. Does the linear need to be divisible by the second? It does. Well, essentially, it needs to map into it when you transpose and you do the kernel. When you do the kernel process, so it needs to at least. All right. So here's the shape at the point of breaking. So yeah, basically, this is the point of breaking here. So we'll print this out twice so we can see that. Okay. Okay. So here it is. Where'd that go? Where'd that go? Features. Output.shape. Size. Okay. Torch. Should that... Oh, do we have to do size and not shape? Like, that might be a NumPy thing. Let's see. Size? All right, do it. We'll figure this out. It's X by X. Yeah. Size. Did you mean size? Okay. I figured. We're not dealing with C# here, so... in Python. Okay, we got it. It is... Yeah, it's supposed to be a 2D... Or sorry, a 1D matrix with two values. However, it's giving us 32 values. So you can see here on the screen. 32. Which is the only issue with the labels. Like, the model works fine. The model works fine. The output labels... Why is it giving me 32? I set it to 2. So this is something I'm not used to because I've... obviously, if I was doing this myself by hand, we'd have full control over it. However, it's giving me an output size of 32 points. As you can see here on the screen, we only want 2. We don't want it to be 32. And for whatever reason, this, even though I set the output to 2. I literally said the output is 2. It's giving us 8. Or sorry, it's giving us 32, which is a lot bigger than 2. A lot bigger than 2. Which is, it's multiplying, right? Yeah, it's multiplying. You got it. It's absolutely multiplying. So it's very simple, straightforward matrix multiplication at this point, at this output layer. So it's all right there. All right there. Very easy. Super, super easy. 16 by 2. Yeah. 16 by 2. I mean, you got the right numbers, right? That adds up to 32, right? Yeah, it adds up to 32. It is multiplying an output here of 32 by 16, and it transposes to 16 by 32 to import into this. And the final output resolution should be a 1 by 2, I think. Right? I'm thinking this is right. Okay. What if we reduce this to there we go. We do, well, we're messing around with things here, so we'll go 16 and 16. See if we can make that work. Flatten the layer. I think you might need 2 flattens. Look at the docs. Okay. So we need multiple flattens here, maybe? All right, let's try flatten again. We double flattened now. Nope, still, it works fine. Let's see. Yeah, so output size 32. It should be 2. I have it set to 2. And, all right, so let us consult, because I do got to get going. We'll ask the AI. We'll ask the AI for help here. Gemini. Let's see here. Output is 32. Okay. Let's see. Let's see if we get a little bit of help here. Usually it means error happened earlier, specifically flattening, blah, blah, blah. Temporarily change the linear layer. Set the input of the first linear layer to any number like 1. Print the shape and print statement forward. Yo, I'm back. Blade Z, how's it going? Welcome on in. Happy to have you here. We're getting our AI going. Oh, we got to do a sequential classifier. Okay, so we need to split these out. So our linear block and our 2 by 2 at the end. Features and classifier. So we got to separate. We got to separate this. I feel like you don't need to separate it, right? Automatically find the flattened size. We pass a fake image through the features to see what comes out. Size, interesting. Oh, in size, and then that goes in here. Oh, that obvious. Okay, we don't need to worry about that. I'm doing that manually. Final output with 2. It's supposed to be 2. Convolutional neural network. Yeah, you're right. Drawing Brothers. Hey, how's it going? Welcome on in. We're getting our AI going here. Final output is 2, but it's not though. It's not. Maybe we need to do a max. We are doing max tool 2 by 2. It's still not working though. Input size, blah, blah, blah. Final layer, ensure you aren't accidentally calling an older version of the model that stopped at linear 32. Softmax. Are we? No. So even the AI doesn't know. No, it's regression. I feel like Claude would give you a cleaner response on this, but it's not. I know. Yep. Raw looks good. Yep. Happy. Current regression head. usually no final ReLU or softmax. Yep, exactly. Exactly. That's what we're doing. Calculate flatten size dynamically. I don't care about that because we were doing it manually. Okay. So this is what we'll have to do tomorrow. I think this will be the thing for tomorrow. So we'll go through and figure out how to debug this part of the page. We're really close. So we've done the hard work. We've done the really hard work. We've got the model that is all set up. I manually calculated the output on this for that layer so it can proceed on forward, which is fine. Your input shape is super duper weird. Features. Really? Is that? Oh, no. That's fine. That's fine. That's actually fine. Those are the coordinates. So it's x, y, x, y, x, y. So it's 6 coordinates. So it's 3 x's and 3 y's. Never. So it's 3 x's and 3 y's. And so that's the input. What's 9 plus 10? 19. Use this UNet. Oh, is this UNet? This is just standard convolutional neural network. 21. Yep. Okay. 21. What time are you streaming tomorrow? That bell notification doesn't work. The jam. Y777. Like the input shape. The in like in the shape. The shape should be where's our shape at? So our input shape is really clean. So here, this is it. This is the features, right? That's the input. It's 3 x's and 3 y's. So you get 3 clicks essentially. So we're doing 3 clicks at a time, right? So that's what the picture is. And then we convert that using your encoder, your CNN encoder that draws a picture with a whole bunch of zeros on it, a blank canvas, and then we put a white dot or white pixel at those coordinates. So x 216 by y 98. So it's essentially like it's going to put the pixel there, and then it's going to do another pixel at 71 by 87, and then another pixel at 756 by 74. And so that's the input. Oh, never mind, you're reading wrong. Okay, shape 1, debug shape 16.2. Got it. So now, so stream for tomorrow, I'm thinking around 11. Let me check. Yeah, a little bit after 11. A little bit after 11 Pacific Standard Time. Technology is moving so fast, I don't know how many futures. I know, right? Your future is going to... We're approaching the singularity, which is the point where the horizon becomes ununderstandable, like incomprehensible. We can't see past it. It's sort of like when you look out over the Earth and you see the horizon, you can't see past what's after that. We're essentially there right now. That's where we're at. It's hard to see what the future is going to be. Okay. So thank you everyone for joining. Neva, if you run into anything, let me know. The issue, you're returning a batch from forward, but trying a single label. Oh, is that the case? Is that all it is? Is there background music? There is. Can you hear it? Can you hear the background music? Okay, so if that's the case, then let's try that. Output. Huh. Yes, you tested it. Print, output, labels. Okay. Okay, there we go. All right. Here we go. Labels and output, yeah. So to me, this looks like a one-dimensional output on the matrix. On the output is one-dimensional matrix with 30 of a length 32. And our labels, which is the target, is also one-dimensional, but a length of 2. And so I can't understand why it's giving me 32. No, it's a 16 by 2. Oh, really? So there is no more pure data to train AI on. Oh, right. As more than 50% of the web is now AI generated. So going forward in the future, it's just going to eat itself. Batch size is 16. Got it. Why? Well, batch size. We're really only doing a batch size of 1. How? Because when I. Oh wait. Do you know Google Summer of Code? I remember Google Summer of Code. Yeah. I've never been in Google Summer of Code. But it looks like, it sounds like a really great program. Okay, so you're saying that the batch size, so it reads as a batch, you need to make it an array holding 1 sample. Yes, I would love to do that. So encode here, right here. So this, is this not the right way? Like, did I mess this up? This seems right to me, because this is like one batch, right? So here is one batch with 1 picture. So add a dimension, like a 1 or something, 1 like that. Okay, we'll try it. You were a mentor for Google Summer of Code for Ubuntu KDE once. Savon, really? Very cool project and smart students? Nice. No, you're right. Weird. Okay. Well, I'm going to try it anyways. See what that does. Very, very big matrix now. Okay. All right. We'll copy and paste this. Where was that at? 46600 is now this. Okay. All right. Oh, whoa. Oh, hey, things are happening. Oh, Neva, you got it. You figured it out. Neva, look. Oh, we did it. I was about ready to give up. That I was like, hey, we have to go. But look. It's working. It's we might have to change up a few things, but it is doing something. Hey, we got it back. All right, we did it. Neva, look at that. Hey, things are happening. Hey, what a great. All right, now it's gone forever. Oh, it's back. Okay. Hey, we did it. It's still centering. It's still grabbing in the center. Oh, we'll have to do some more things. This is really neat. It is learning. It's learning. It's doing a lot better than it was before. Like, there we go. What? Push it and I want to read why it works? Me too. I don't know why it's working. I just want to try it out. Open source is now an AI code dump zone, isn't it? It is. You're right. You're absolutely right. Wow, so cool. That was the culprit. What was the culprit? We were using a 3D, three-dimensional matrix, and it wanted a 4-dimensional matrix. Who would have thought? It wanted 4-dimensional, so I did 4D. Here we go. Isn't that neat? Click. So this is me clicking. Wow, look at that. This is so neat. Okay. All right. We do have to do an encoding bounding. We have to do encoding bounding. So when we decode it, we'll have to figure this out. We'll play. Oh, see, circle's coming back. It's coming back. There it goes. It's on its way. Nice. This is great. This is neat. Hey, we did it. All right. Well, I guess we'll, but why it wanted 4D? I don't know. Neva was like, hey, why don't we try 4D? And we did. So here, check this out right here. This is where, I don't know if you can see it on the screen. I'll put it into the center 1 second. Down, medium, here we go. Right here. That's where it is right there. Thank you for the likes, you guys. We did it right before we were about to head out. All it took was an extra 1 comma in there. Just a little bit one. And we, of course, we also had to update the output coordinate here as well. We had to change that. So 0, 0, and then 1, 1 here. Yeah, we did it, you guys. We did it. All right, thank you for joining, everyone. We had a great stream. Let's run that again to see what that looks like, just so we can call it out. and limit streaming text to 1 line, 2 line, cut some of the part. Oh yeah, because it expects a feature dimension. Ah, there we go, feature dimension. All right. Oh, probably because of color, right? The channels, right? Red, green, blue, alpha. Red, green, blue, alpha. There we go. And so we needed batch and the features for the channels and the number of samples. It's technically bugged right now. Then, as far as I know, it's working. My usual, right on time. All right, you're right on time, and we're headed out. Yeah. You got it. Nice. All right, we did it. It's looking pretty good. So now all I want to do is change how we're training the AI. Change some of the models. Change what it's seeing. Maybe add more pixels to the picture so it knows what the last like 10 pixels are rather than the past 3 pixels or the coordinates, right? So there's a lot of things. So that's what we'll do tomorrow. We'll see if we can improve it. We got it working. I would send a PR fixing the shape issues. All right, sounds great. Before I do that, let me commit this here. See here. Git status, git add clicks and main, git commit m. Send the PR. Send the PR. CNN working. Okay. Push. There it goes. All right, bye you guys. I am headed out, but more weighted. It looks like it's still an average. It does, yeah. It does look like it's still an average. I think we can fix it. See you guys. Yep, we're headed out now. This was an incredible live. Thank you, Sivan. Thank you, everyone, for staying. Thank you, Neva, for helping us out. Kyle, thank you for hanging out. And Drawing Brothers, great to have you here. And everyone else as well. It was good to have you here. And Torva, of course, as well. Good night. Cool. Thank you, everyone. We'll be back tomorrow. The plan for tomorrow is we will improve this model now that we have a CNN that's working and we actually see that it's giving us pretty clean output. We'll optimize it. We'll make it better. We'll see how well we can make it. I think we can do a pretty good job. All right, everyone. Thank you for spending time with me today. We'll be back tomorrow. Good to see ya. Bye, everyone.